Priyanka, madam,
Yes, sir.
you can start, madam. The participants, let them join.
Okay, sir. Sure.
Okay.
Good evening to one and all present here, esteemed dignitaries, distinguished speakers, respected faculty members, and enthusiastic participants. It is with great pleasure that I, Priyanka KR, Assistant Professor of Information Science and Engineering Department, AMC Engineering College, welcome you all to the day 3 of this insightful faculty development program on Future Ready AI, emerging technologies, and their societal transformations. Over the past 2 days, we have delved into the dynamic landscape of artificial intelligence, uncovering its profound implications across industries, education, governance, and beyond. Today, as we embark on yet another day of exploration and intellectual discourse, we continue our journey towards understanding AI's transformative potential in shaping the future. Today's sessions promise to be intellectually stimulating, feature thought provoking discussions on cutting edge AI paradigms, ethical considerations, and the societal shifts that accompany technological advancements. We are honored to have with us the esteemed experts who will shed light on emerging trends, bridging the gap between theory and the real world applications. Let us embrace this opportunity to challenge conventional perspectives, foster meaningful collaborations, and cultivate a vision for the future where AI serves as a force for positive societal transformation. With that, I extend my warmest welcome to all of you and look forward to an engaging and enriching day ahead. Now, I request Dr. M. Ashwin, coordinator of FDP, to share a few thoughts about the next sessions of FDP being conducted. Over to you, sir.
Thank you, madam. Yeah, very good evening to everyone. There will be a slight change in tomorrow's schedule. The session 7 has been swapped with session 13. Therefore, tomorrow session 7 will be handled by Dr. Amudavel Jayvel from D. Montfort University, United Kingdom, on the topic of high performance computing with digital twin. Session 13, which was originally scheduled for tomorrow, which will be held on Saturday and will be conducted by Dr. A. Murugan from SRM Institute of Science and Technology, Chennai, on the topic of AI application in healthcare. Today, we are honored to have the esteemed industry expert, Mr. Gopalakrishnan S. from Philips Private Limited, Bangalore, will be delivering a session on AI application in autonomous system. Now, we request Professor Priyanka, madam, to introduce our resource person. Over to you, Priyanka, madam.
Thank you, sir. So again, I welcome you all with a very good evening. It is an absolute honor and privilege for me to introduce today's distinguished resource person, Mr. Gopalakrishnan Sriraman, a seasoned IT transformation leader with over 22 years of extensive experience spanning various industries, geographies, and leadership roles. Mr. Sriraman is currently the Director of Hyper Automation Discovery and Platform Services at Philips India Limited, where he leads a global team focused on driving enterprise wide automation initiatives. His expertise lies in lean, agile, and DevOps, that is, which is development, security, operations methodologies, which he has successfully leveraged to steer large scale transformation programs that bring tangible business outcomes. His illustrations career includes key roles at Accenture, iGate, Oracle, and Wipro, where he has been instrumental in program and project management, IT strategy, quality assurance, and performance management. With over 14 years of managerial experience, he has effectively led cross functional teams, driven agile and DevOps transformations, and implemented business process improvements that align technology with organizational goals. Academically, Mr. Sri Raman is highly accomplished. He holds an executive general management certifications from IIM Bangalore, an MTech in Information Technology from Anna University, an MBA in Finance and Investments from ICFI, a BE in Information Technology from Periyar University. His passion for continuous learning is reflected in his numerous industry certifications, which includes SAFE SPC Consultant, which is Scaled Agile. He has also held certifications of Project Management Professional PMP from PMI, Agile Certified Practitioner, Azure Cloud Fundamentals from Microsoft, excuse me, Sales Cloud Pre-Sales Specialist from Oracle, ITIL Foundation, among many others. Excuse me. Beyond his corporate achievements, Mr. Sri Raman, excuse me, sorry for the interruption. Beyond his corporate achievements, Mr. Sri Raman is an active contributor to academia. He serves as a Board of Studies member at Sona College of Technology and has delivered expert lectures on decision thinking, agile software development, DevOps principles, and project management at various institutions. He has also been a key facilitator in faculty development programs on cutting edge software development methodologies. Today, we are privileged to have him with us as he shares his valuable insights on AI, emerging technologies, and their transformative impact on society. His deep industry knowledge and ability to bridge the gap between technology and business make him perfect guide for navigating the future of AI-driven innovations. Let us extend a warm welcome to Mr. Gopal Krishnan Sri Raman, who would be discussing with all of us on the topic AI applications in autonomous systems. We welcome you, sir.
Thank you. Thanks a lot, Professor Priyanka, Professor Ashwin, and everybody. I'm honored and delighted to be part of today's session. And for the next 80 to 90 minutes, I wish I'll be able to provide you more insights that is more industry relevant, that you can take away and enrich on this exciting world of artificial intelligence in autonomous systems. Hope you are able to see my screen. Can any of you confirm?
Yes, sir, we are able to see your screen.
Thank you. Thank you. Artificial intelligence applications in autonomous system. Over the past few years, both artificial intelligence and autonomous systems have evolved in breakneck speed to an extent that anybody who follows these two overlapping as well as distinct domains will be overwhelmed with the advancements. Every day we see new developments happening in this world. With the advancement of latest hardware chips, cloud, Gen AI, and whatnot, this is an exciting space for anybody to be and learn, to be relevant for academics as well as for the industry. So today I'm going to quickly walk you through on the evolution and narrow down with a little more on autonomous systems, how AI is driving with a couple of examples. walk through the advancements, challenges, ethical concerns, and leave you with some food for thought. So, evolution and history. Of course, artificial intelligence is not overnight. Right from rules engine to expert systems in the previous decades to where we stand, the rules, the logics have been continuously abstracted and layered. The advancement and affordability of tech, affordability of network, cloud have accelerated the evolution of artificial intelligence. Of course, the foundational algorithms still remains foundational, and they have been built upon, improved upon in the years, right from 1950s to today where we stand. The advancement of machine learning in 1990s kind of revolutionized this, and the abundance of data made it even more important on how artificial intelligence enables building insights on data-driven systems. In a simple, holistic view, just like any other revolution, right from the first industrial revolution that happened with water and steam engine in the European lands to the mass production of electricity that created a huge advancement and affordability of different electrical instruments to the human life. Then comes the printed circuits, the IT systems with the punch cards and analytics engine and whatnot. And then comes the use of IoT, AI, big data, autonomous, and central processing. And with every revolution, which is built upon the success of previous, one of the aspects to get amazed is the shelf life or the span of each revolution, especially as we get into the IoT, AI, big data, and autonomous. The shelf life of any new tech has shrinked such that before even the hype cycle of the previous tech gets settled, numerous next generation techs gets hyped. Nobody would have imagined 2 years back how or what ChatGPT or GenAI or whatsoever will look like. Nobody would have imagined even 3 months back that DeepSeek will come and disrupt OpenAI, ChatGPT, leading to billions of dollar market loss for NVIDIA and so. So I'm just giving you this couple of examples on how the larger global ecosystem is advancing so rapid. And it's very essential, we as academics as well as the student fraternity, to keep up, understand how the tech is evolving so we stay relevant. So, as I said, the evolution of AI is not an overnight. It's built upon layers on layers on layers of abstraction and algorithms, accelerated with hardware and software, and mechanical, electromechanical, mechatronics coming together. So just give a glimpse all the way from 1950s to today. As you notice, the initial years, the new advancements were in decades. And as we get closer, the new advancements are in years or even quarters and months and days. So the hype of AI, the hype of autonomous systems is no longer a hype, but becomes a foundational hygiene. And autonomous systems and AI are getting embedded in every device that we use. And I could say that inadvertently, without even having consciousness, many of us would have used a lot of autonomous systems and AI in our current life. Right from surfing in YouTube, which I believe right from every newborn does. The moment someone selects a video, automatically the underlying algorithm looks at what kind of videos this person views, and selects you a suitable video, which if you really put an lens, it applies artificial intelligence, where it analyzes the patterns, it looks at whose gadget, which user ID, what attributes, and it kind of does a natural language processing, video analysis, and it autonomously recommends the next set of videos. I'm just giving you this example to see how foundational artificial intelligence and autonomous system are already in our life. And it's very critical we appreciate that fact, and we also understand the nuances of it. So as researchers, as students, we are able to build on that. So we are indeed in the AI boom. If I look at industry, either it's factories or software providers or even the way people buy milk and groceries in the cities are very intertwined with AI and autonomous systems. There is no new factory that is getting constructed even in India without AI in mind, autonomous system in mind. So that's the reality we are into. So if you really peel the onion, a lot of this autonomous systems and AI, especially in the software world, still beneath the surface are built upon the foundational elements which we study in our BTech and MTech. The algorithms, the machine learning, the CNNs, the logistical regressions, the neural networks are foundational. And upon each year, each decade, advancement of layering has happened on top of that. And we are where we are today. And it's also good to appreciate that when we talk about artificial intelligence, there is multiple umbrella of tech that comes in. Again, I just picked this one slide, which is more software oriented. However, a similar approach could be looked at even in mechanical autonomous systems. For example, generative AI literally lives on deep learning algorithms. Deep learning leverage mechanical machine learning with large data sets. Machine learning is a subset of artificial intelligence coming together. So technologies or systems that mimic or replace human intelligence, we call it as, at a very high level, artificial intelligence. And if that automatically learns rules by analyzing data, then we give them a term of mechanical machine learning. And if that machine learning is able to process information based on neural networks that kind of mimics the human brain, then comes the deep learning. And if that is able to generate new content based on user demands, then that's generative AI. And for me, even this slide is outdated. What we have today is the next agentic AI. And if generative AI, instead of just generating new content based on user demands, able to autonomously take decisions based on the generated content, based on mimicking the human brain and analyzing data, then that is agentic AI. And large organizations like Tesla's and Microsoft's and NVIDIA's are today working on agentic AI, where AI take decisions autonomously. And that's a culmination of bringing autonomous systems and AI very together. So before we deep dive further, it's also very essential to understand a bit of various types of artificial intelligence. And again, there are multiple researchers and academicians sliced and diced it in different forms. And in this one form, when we talk about artificial intelligence, we call it a strong AI and weak AI. And when we talk a strong AI, it's a general intelligence and super intelligence where we are able to have broad-based. And when we talk about weak AI, it's more based on rules, based on specific boundaries, rule-based systems, expert systems, and so on. Each focused on specific purpose, specific capabilities, algorithms, and as and more various narrow intelligent AIs combines together, then that also leads to super intelligence and general intelligence of strong AI. And if I really peel the onion, in a sense, if someone who doesn't really understand too much on tech and doesn't get carried away, end of day, there are inputs, there is a set of processing, and that processing are the hidden layers which leverages various algorithms, which leverages various techniques of deep learning, machine learning, leverages a mass volume of data, process them, and provide certain outputs. And as it does it, it also enables not just providing outputs, but also ability for interactive explanations, cross-disciplinary explanations, leading to generative insights. So when we talk about artificial intelligence, it's about how intelligently we are able to process the inputs dynamically, real time, in various attributes, various parameters, adapt it with the situations, with the attributes, and provide the right outputs. More personalized to the problem, more personalized to the needs of the end user or the system. And to make autonomous systems work, that if a system need to be autonomous, it should have an ability to learn. It should have an ability to adapt of various inputs and provide the right outputs to take decisions. And that's where AI becomes more foundational for driving autonomous systems. And I also want to articulate, when we talk about AI, as I shared you in multiple other slides, there are different ways of looking at it, right from natural language processing, where you are able to understand, interpret, and generate human language. And today, it's almost in everybody's life, as you use a computer, as you use a phone or a tablet. Able to learn from data, make patterns, make insights with machine learning. Similar to text, also ability to process, interpret visual information of image and videos. That's the computer vision. And integrate that with IoT, with mechatronics or mechanics, and physical devices to automate tasks, perform physical actions, which we call as robotics. Also able to represent knowledge from large data sources, discrete. That's a knowledge representation. And if you use Facebook or whatsoever, then you will be experiencing it without even knowing that you are experiencing it. And as we move towards from 1 to 5, you will see that the first 4 are distinct capabilities. And as they get abstracted and improved with knowledge representation, then comes decision making. The ability of a machine to make decision and plan actions based on the goals, the rules, and the expectations. Leveraging the knowledge representation, leveraging robotics, computer vision, machine learning, and natural language processing. And that's decision making. And for making decisions, as the intelligence and autonomicity improves, it is essential to have reasoning capability. The decisions are not just based on rules. For example, we say that this is a sensor. If the sensor's temperature is increased beyond 90 degrees, shut down. If some of you are using air conditioners or geysers to cool your house or to heat the water, the decision-making system is there. The expert system is embedded in that. It has sensors. It checks the temperature. It uses IoTs or machine learning or whatsoever. And based on the temperature, it takes decisions to control the flow of energy to heat or cool. And as I said, you will not recognize that these systems are already in your house today. But then if you really closely look at, they are there, and you just need to be curiously looking at them, how they work, to understand some of this tech that's already embedded in our day-to-day life. And nowadays there comes even a air conditioner with a voice control, and that leverages NLP and machine learning. And beyond decision making, in this case, there is a sensor, there is already a program done. If temperature goes beyond 90-degree, flip the switch. So this is decision making, but it is rule based. However, human intelligence is not always rule based. It goes beyond it. And for a system to be autonomous, of course, rule based situations work, but beyond a point, rule based systems are not just good enough. And that is where reasoning comes into. It's not just about doing what the system is just coded to do. It's also about the system starting to understand why it is expected to do what to do, and also start thinking what should be done in a situation, even if it's not coded there. So that's the ability of machines to draw the inference, make predictions, and solve problem based on the knowledge and understanding of the world, not just on the rules written in the chip or sensors, but also ability to reason and adapt. Then the most complex one on natural interaction. The ability of machine to really interact with humans in a natural and intuitive way through speech, touch, or gesture. For those of you who are having an Android phone or iPhone phone, you just talk to the Siri or OK Google. It interacts with you. You ask it to play a song. You ask it to make a phone call to a person. It understands your tone. It understands your commands. It understands what you ask for. Does the natural language processing, does the knowledge representation, take decision what to do based on your ask, and gets you to the next step to make a phone call or play a song. So that's the natural interaction. Again, I am oversimplifying the concepts to something that you already can relate to in your daily life, so that it becomes easy to appreciate and understand. So as you see, artificial intelligence is not just the complex algorithms and the transformers, which are very difficult to learn, the digital signal processing and things which people really find it very difficult. The application of artificial intelligence and autonomous systems are already around us. We just need to look for and appreciate. And I always, when I go to the students, I say, yes, if you want to really learn something new, just look around and try to find why and how it works. What is behind how YouTube works, or what is behind how a specific toy work, or a specific electrical appliance work in the house. Then you will understand the autonomous systems and artificial intelligence are already there and even more getting sophisticated every year and every month. And as we get into the autonomous systems, there is also a simple taxonomy where we say autonomous systems are defined as systems that can perform tasks independently without human intervention. It can be fully autonomous, make decisions without human input. It can be semi-autonomous, where there is still certain human supervision or input are required. Of course, in India, self-driving cars are not yet a very phenomenon. But if you really look at the Western world, the self-driving cars are one of the epitome of autonomous systems. And nowadays, I also see a lot of drone tech, even in Indian world, which uses a lot of autonomous systems. So when we talk about autonomous systems, it can be fully autonomous or semi-autonomous based on the needs. For example, in health tech, in my own organization, we have a lot of semi-autonomous systems where by purpose, we still believe humans are required in the loop, human in the loop to take certain health diagnostic decisions. But the autonomous systems leverages digital signal processing, leverages computer vision, sensors, and provide a lot of information in a more curated way to the radiologist or the doctors so that the humans can interfere to take the right decisions. To give you an example, in the health tech where I belong to, nowadays there are autonomous systems. When an MRI scan or a X-ray is done, it understands and customizes the MRI output to diagnose specific disease. And it also goes one step further, looks at the MRI image of the patient, compares it with numerous other reference cases, and provides already a first diagnostic summary of what good, bad, ugly of the health of the patient can be. And in cases like eye surgery or even certain other surgeries, there is already autonomous robots that guides the doctors and reduces their workload in doing razor thin cuts, very, very localized surgeries, very less invasive. And that's the power of artificial intelligence and autonomous systems coming together in a more regulated environment like even health tech. So, as I said, autonomous systems are evolving right from early robots to self-driving vehicles. And self-driving vehicles are one of the complex autonomous tech, which I will also go a little more deeper, where you appreciate how AI and the various different dimensions of AI, what I cut across, flows into. And another one is also the autonomous drones, where the aerial robotics and automations are in full-fledged. And especially the autonomous drones in the defense world is so evolving, and it's very, very even imagine. I was looking at a video a couple of days back where there was a drone from a country. Again, there is a war going on in Ukraine and Russia, where there was a drone from country A traveling to country B to attack something. Then there was another drone from the opposite country, which was a mother drone, which was flying, and it opened up, and there was a child drone from that drone with a small detonator that flew and sat on the opposition's drone and blasted it. So it was literally a drone warfare where one of the drone was followed by a mother drone, which released a smaller drone with a detonator that went, sat on the opposition's drone and blasted. So this was a classic example where artificial intelligence, robotics, sensors, autonomous systems, computer vision, reasoning, and whatnot coming together and in action. So the moment we talk about autonomous systems, it is very difficult to keep artificial intelligence away. And it's more of a twin to each other. Enhancing perception of capabilities of autonomous systems to better understand the surroundings, attitude, latitude, whatnot, improve decision making, faster, more accurate, and adaptability in dynamic environment of changing conditions and uncertainties. So, when we talk about autonomous systems, another way for anybody easy to understand is to go from the bottom. Automatic. A system that responds to environmental input with pre-programmed responses. That detonates something, and then the gun gets fired and the bullet travels. Or you put a key, that key compresses the coil, and then you release it, the toy fastly move forward. So there is always a set of actions pre-programmed, either it's software or mechanical, and that get executed. So that is automatic. Then comes semi-autonomous, a system capable of making decisions based on context, but still relies on human intervention or override for others. So you put certain intelligence, but then you don't provide it a mandate to run by itself. And if not controlled, semi-autonomous has its own negative consequences. Then comes autonomous, where the system is fully in its control. It has an ability to make its own decisions. And of course, sometimes a system might have variables, multiple modes, but if an autonomous system need to be fully autonomous. It should have an ability to make its own decisions. And that foundational capability comes from nothing other than from artificial intelligence. Either it's machine learning, deep learning, generative AI, computer vision, what all different domains of artificial intelligence. And that is what makes autonomous system truly autonomous. So when I got this topic of AI in autonomous systems, I was also a little bit curious, because for me, beyond a point, autonomous systems doesn't even exist without AI. And that's how they are intertwined. So, as I said, automation, executing task based only on a fixed set of instructions. Simple robotics, where you write code, you put move from A to move to B, reduce your arm from 3 feet length to 3 centimeter length, run the rotor, run the motor, do welding, and for 6 seconds, pull it up. Then again, repeat the same for the next. So that is a simple robot that is automatic, simple automation. And when we talk about autonomy, then independent, real-time decision making based on a set of rules, but that also goes beyond and adapts on the situations, like self-driving cars or to an extent drones. So the control and complexity is not binary. It's has a band based on the use case, based on the need, right from automatic and reflexive to autonomous, independent to interdependent. No world model, simple rules, does what it is expected, to a very comprehensive model where it adapts, it leverages, it builds its own. So the control and complexity varies from low to high based on different applications and use cases. It's also essential to appreciate where you need automation, automation is good enough. Where you need autonomy, autonomy is good enough. There is always a trade-off, especially when we put an industrial lens. What need to be automated need not be autonomous. What need to be autonomous need not be just automated. So it's ensuring the trade-off between cost, control, complexity, compliance, regulations, sensitivity, and of various factors. When I take a simple one more step back and see, okay, we talked about autonomous, we talked about AI. And I also want to give you a simple sense of just taking machine learning as an example. When you have autonomous systems, you have to have control, and that control comes from the learning. And when you have a need for interacting with different parameters, surroundings, you need to have your sensors, you need to have your Internet of Things, your connectivity. If your use case need cognitive computing, it need to have ability to understand, reason, respond, and learn. And if your use case is truly general intelligence, where it's a master of all, then it need to have far broader knowledge, far broader real-time processing, domain-independent problem-solving capability. So when we talk about autonomous systems in the context, we are essentially talking about an umbrella of capabilities, umbrella of technologies, umbrella of constructs. And based on your specific use case, application, or a business problem, you figure out what are those components that place comes together, get abstracted to build that autonomous systems with foundational AI. And these days, as I said, artificial intelligence or autonomous systems are no longer just hyped topics. Almost every person connected to internet, every person who is using some sort of smart gadgets at home, smart TVs or what's, you end up using autonomous systems, using AI in a form. It could be for information retrieval, it could be for cognitive commerce, it could be for monitoring, it could be for manufacturing, industry, elderly care, and whatnot. So, as I said, becoming truly autonomous requires decision making and control. And to do decision making and control, the AI algorithms facilitate the decision making by processing large scale data quickly and efficiently, allowing for immediate response. The AI algorithms are leveraged by the autonomous systems to navigate and perform tasks independently, enhancing the overall efficiency. The AI algorithms are equipped with capabilities for obstacle avoidance, for ensuring safety and reliability of operations, so that the system runs autonomously, long sustained. So, when we look at the applications of AI in autonomous systems, as I said, virtual assistants, autonomous vehicles, health tech, smart home devices, financial and banking, retail, education, language translation, gaming, robotics. So there are tons of opportunities, project cases that students as well as faculty can embrace and leverage to understand and appreciate. Nowadays, for example, language translation, there are devices where if a person talks in a language A, let's say a person talks in Kannada, the other end, the person hears it in Hindi or Tamil in near real time. So that is the power of AI, and that's the power of autonomous systems that comes in. So to narrow down, especially in the case study, what I picked up for today, that is basically the automated vehicles. There are also a few specific AI technologies that comes into the play. That is the role of sensors. When we really want a system to be autonomous, it has to really see, listen, feel, understand, hear what is going around it 360-degree. And that's the role of sensors that comes in. that provides continuous flow of data, insights of the environment. The computer vision, where yes, the sensors provides a lot of data, but that need to be processed. If the data is text, if the data is image, if the data is video, if the data is some parameters, then the natural language processing, the machine learning, the computer vision essentially interprets, understands the visual information and navigates through, and then respond it to the humans or to the systems and facilitate better interaction. So when I try to apply these concepts in specific use cases, self-driving cars, where the autonomous system leverage AI to navigate the roads, the safety, the efficiency of transportation, what is coming, what is going, who is driving, who is behind. Then robotics and manufacturing. Nowadays, the industry calls them as, dark factories, where they're manufacturing machines, they're manufacturing cars, or they're manufacturing mobiles or toys or whatsoever, but they don't even need light in the factory because almost everything is automated, and the human is simply sitting in a corner in a command center, and it is the robots that is actually doing the manufacturing, assembling, packaging, printing, and whatnot. So AI-powered robots transforming the manufacturing process by automating tasks, increasing productivity and precision. Then drones is another example. Aerial tasks, delivery, surveillance, and nowadays drones are essentially used for, even in agriculture, to spray weed killers and fertilizers in a more better way than someone physically doing it. So drones and robotic in manufacturing and self-driving are excellent examples of artificial intelligence in autonomous systems driving. So let's narrow down on autonomous driving. So when we talk about autonomous cars, we are basically talking about a self-driving car, a vehicle that uses a combination of sensors, AI to travel between destinations without human operator. Of course, for a country like India, for a city like Bangalore with all the traffic and potholes, I'm 100% sure we are far, far away from an autonomous car to work. The car will just get busted and curse us as humans how what we have done to the roads and traffic in a lighter note. But in countries like US or Canada or Europe, today autonomous cars are, and there again, for someone new to understand, we need to understand the levels of autonomicity. It did not happen overnight. The Tesla FSD 4.5 or whatsoever today did not happen overnight. You have level 0, where the driver is controlling the car without any support from driver assistance system. Everything is mechanical. The brake, the speed, the accelerator, the windshield, everything is mechanical. Then comes adaptive lane assist or parking assist. And nowadays in modern cars in India also, in premium cars, these are standard feature. Adaptive lane assist or parking assist, where the car helps you guide park better. Then comes steering and lane keeping assist and remote controlled parking. Especially in highways, if you want to just stay on the lane, continuously traveling in a constant speed, then the sensors, the robotic instruments in the car kind of helps you stay in the lane and do remote control parking, but still human is driving it. Then comes the driver can, in certain situations, for example, if you are in outside the city, if there are no traffic on the road, then still the driver can relax a bit and the computer and the autonomous vehicle kind of drives it to an extent. But the moment there is some obstacle, the moment there is some traffic, then the system simply alerts and the driver takes over the steering and drives it. Then comes the level 4 for fully automated driving with no hands-on steering. Then the level 5, which is today also a reality, is the fully automated without human input. So yeah, I think since I spoke enough on this in the previous slide, I'm not going to really talk on, but that's how the different automation levels in automation costs has evolved over the last 1-2 decades. And what is the tech behind it? How does it really work? And as you see this picture, there is a car, and that car has different capabilities. And these capabilities are a combination of artificial intelligence, sensors, mechanics that comes together. Long-range radars, lidars, cameras, ultrasound, and the information that is gathered from various these sensors and input devices then are fed into real-time artificial intelligence, real-time computer vision with AI-enabled chips that kind of takes decisions to stop the car or to turn right, turn left, to reduce speed and whatnot. So the advanced driver assistance systems are focused on collision avoidance, lane departure warning, blind spot applications. And this is one classic example of artificial intelligence, mechatronics, and autonomous systems all coming together. And I just want to play a video for a minute, which you will also appreciate. And this is also kind of gives you a sense that this is not something just a theory. It is not something just you read in books, but in reality.
So much emerging technology is just a show, so one can be forgiven for not being able to distinguish fact from fiction. Take this car, for example. Can it drive autonomously or not?
The short answer is absolutely.
That was Shweta Shrivastava, Senior Product Lead for Driving Behavior at Waymo.
What you're looking at is the Waymo driver in action. Adapted for a variety of vehicle platforms, it is the most advanced, fully autonomous driving technology in the world today.
What you notice pretty quickly is that these aren't normal vehicles. Take this Jaguar I-Pace, for example. It's been equipped with an elegant array of sensors and software, which allows it to move through the city on its own.
That's correct. The Waymo driver is a combination of custom design, hardware, and software that is responsible for performing the entire act of driving.
That was James Philbin. He's an engineering lead on the perception team at Waymo. I asked him to break down the technology for us a bit more.
The Waymo driver handles the task of driving in 3 basic steps: sense, solve, go. It's the way we describe the highly complex process of acquiring information, processing it, and moving through the world safely.
So, what goes into all that sensing?
The sensors that the Waymo driver uses are incredibly powerful, using a combination of LiDAR, cameras, and radar. It can see up to 3 football fields in any direction and can detect sirens from emergency vehicles, which allows the Waymo driver to visualize the world around it in milliseconds to a high degree of accuracy.
Okay, sense makes sense. But what do you do with all that data?
Good question. The system calculates the predicted future behavior for each relevant agent in the scene. Then, with a strong foundation derived from artificial intelligence and machine learning algorithms, the Waymo driver crunches all that data and calculates a safe route while responding in real time to the evolving traffic environment.
If I understand correctly, this means the Waymo driver continues to learn as it goes, is trained and tested on scenarios that it's never seen before, and can differentiate safe and comfortable driving behaviors from hazardous and uncomfortable ones.
Yes, well done.
Why, thank you. Final step in the sense, solve, go methodology is perhaps the most straightforward. Go.
Once the Waymo driver has determined the path to take, our advanced motion control systems allow for smooth acceleration and braking on hilly streets, or managing bumper-to-bumper traffic with safe and natural driving movements.
So it's really here, right now in cities. Not smoke and mirrors, but true autonomous driving technology. Waymo is taking what was once futuristic sci-fi and making it non-fiction. And like all great technology, all that number crunching, all that data just fades into the background. Did you realize the dream of riding in a fully autonomous vehicle to your favorite dinner spot isn't just a vision of the future? It's actually happening right now.
So Waymo is technically a Google-funded company, and they have their autonomous cars just like Ola in Bangalore. You can book your car, it comes, you sit, no driver, and then it travels in San Francisco and drops. And the very reason I took non-Tesla example is many people think Tesla is the only company that does it. Nowadays, there is a lot of companies who are also accelerating the autonomous driving tech across. And of course, Tesla is still a torchbearer in this area, far evolving and more matured autonomous tech, leveraging artificial intelligence. And again, if this was one of a simple oversimplified architecture diagram of Tesla's Hydra net, which it basically is an operating system of Tesla. And what you see here is, you will see all the artificial intelligent algorithms and names. So there are video images that get extracted. There are from sensors across 360. They are transformed through CNNs, RNNs, transformers, and then decisions are taken in real time at the fraction of second when a vehicle comes between or crosses or it rains. So such a very sensitive on the roads, autonomous systems behind the scene are nothing but driven by artificial intelligence and the hardware supporting to it. Of course, Tesla also has encapsulated all the artificial intelligence and machine learning and computer vision tech into its own chipsets, so that AI is deeply embedded in the autonomous system and driving it. Of course, just like any other tech, it has evolved. The autopilot 1 and 2 were more of semi-autonomous. But as Tesla is able to leverage and drive and optimize, it is able to go into almost full autonomous, leveraging the full capacity of artificial intelligence, machine learning, computer vision, and then applying that into autonomous systems and driving it. So again, this specific tech started somewhere in 2010s in research labs, and then in 2014 into Tesla's journey. Numerous improvements of sensors, radars, perception sensors, surroundings, software updates, regulatory advancements, which is again critical, all drive to where it is today. And this is happening in real time, right? And that's the power of artificial intelligence encapsulated driving the autonomous tech. Again, I just noticed I have less time, so I'm going a little more faster to a couple of slides. So all the different tech, all the different components and elements of artificial intelligence comes together to drive autonomousity in it. And another aspect I also want to quickly touch is agentic. We talked about all the hardware, what is driving in drones and what is driving in vehicles. But there is another aspect, totally a different autonomous system, which is software autonomous system, where the co-pilots of the world are agentic and doing things. If you need a secretary, you need a person in your office to do some mundane task, the AI agent can do it for you without even having. And that is where the existential crisis of KPOs and BPOs comes into process. For example, today a lot of humans does business process outsourcing, lot of documentation, optical character recognition, invoice processing, sales order crunching, and autonomous system AI agent are doing that without even needing a human in the loop. Driving perceptions, driving reasoning, taking actions. So if somebody is more interested in learning about it, agentic AI, which is basically the next of generative AI, you can just Google around on Microsoft Copilot or GitHub Copilot, which writes even software code automatically. You just tell it, I need a Python program to develop a CNN algorithm for this input, for this output, for this domain. It basically builds it and creates it for you and gives it in hand. So agentic AI and generative AI are the software side of it, which is more into the enterprise applications and operations, autonomous system driven by AI, automatic decision making, executing tasks, handles multiple workflows, complex workflows, continuously takes decisions, enriches it, automatically supply chain logistics, troubleshooting systems, and whatnot. So as all these are evolving, the other thing you should also be keeping yourself mind is the footprints, the ethical considerations. So one side, everything around you is becoming autonomous and AI driven. And the other side, this also increases the risk perceptions. This also increases the regulatory ethical connotations. Manufacturing and assembly lines, in logistics and ride sharing, in diagnostic system and robotic surgeries. So this is not future, this is today. So it requires a lot of regulatory catch-up and ethical catch-up considerations. And that is also a complex challenge every government and every company and industry is facing. As I said, energy, retail, agriculture, you have AI-driven autonomous systems right there. So that also leads to a much more need of research and development and faculty program like today, where faculties understand, students are already equipped to find jobs, do things in these areas. And that kind of also enables further more robust and trustworthy autonomous systems. Doing pilot projects, testing feasibility, building workforce transition, where every company is going through, how do I really reskill and upskill the employees to live in the world of AI-driven autonomous systems? And how do I really ensure my compliance and regulatories? So when I talk about positive impacts, increase efficiency and productivity, enhance safety, improved accuracy, precision, far better cost reduction, breakthrough in innovations. But at the same time, there is also a lot of societal and ethical impacts that comes into the play when you really drive artificial intelligence and autonomous systems. Job displacement and workforce disruptions, where people need to really reskill themselves, find better jobs. And if their job is simply mundane, what an AI-driven autonomous system can do, then they probably are jobless very few soon. Privacy and security concerns. The moment all the data and the system can start processing them autonomously, unless you enforce privacy and safe security. Ethical consideration in decision making. For example, few years back, Twitter was seen and proven to be taking certain biased outputs, certain biased decisions in the Twitter algorithms. So the moment you are driven AI, if there is a bias, that bias kind of builds on it and skews the results. So that's also an impact that need to be considered. And just like income equality, having ability to access the autonomous systems is also creating divisions in society of haves and have-nots. So, of course, when we really appreciate that artificial intelligence in autonomous systems, since the title for me was also to explore all the ethical and the limitations as of it, so I also want to kind of articulate that tech is already there today. It's not future, it is today. And it's also evolving fast in the future, for the future. But as research and students, you should also appreciate the positive and negative impacts that comes to it. And it's very important the transparency and explainability of the algorithms, the transparency and explainability of the decisions. If you are in an autonomous car, if the autonomous car is taking right or left, how is the coding, how is the algorithm, how is the machine language, how is the sensor taking that decision? Can it be audited? Can it be documented? Can it be explained in what situation it's supposed to take right and what situation it's supposed to take left? To bring that ability of explainability and transparency becomes very, very critical when we build AI-driven autonomous systems. And of course, the industry governance also catching up. There is a lot of new regulations, AI acts that are being discussed, being put in place by governments, by central global bodies. And it's also work in progress since this technology is also evolving. And there is a great opportunity for us to contribute to these frameworks as well. Ethical AI framework, human AI collaboration, what it means, how do we really continuously monitor and improve this AI-driven autonomous systems, address performance issues, and so on. So there is already an IEEE global initiative for ethics, autonomous intelligence systems, that is building frameworks, doing research on the next steps and practices. And there is European Commission for Ethical Guidelines. That's another large body that is driving some of these frameworks and practices. And of course, it's also an imperative for every research organization and industry to evolve. And again, there are certain laws like Moore's law on robotics, on AI, that is being explored, being discussed, and so on. And it's very critical that when we really build AI for autonomous systems, we take in consideration of these laws and ethical considerations. And as I said, bias is another biggest challenge. Minimizing the biases by doing proper algorithmic evaluations, data sets, and ensuring that there is no informed pollution of these biases that gets into the systems is critical for the success. And there comes the importance of data collection and processing for autonomous systems. Unless you have well spread representative data sets to build your algorithms, train, test them, and also be mindful of the potential bias and implement steps and train them to mitigate those biases is very critical. Promoting fairness by preventing, mitigating biases, development of algorithms that kind of takes care of the societal and cultural differences, fair treatment, and avoiding reinforcement of discriminatory biases that gets into. So these are some of the foundational algorithmic design and development considerations that as researchers, as faculties and students to consider when we drive applications for AI-driven autonomous systems. And of course, again, audits and assessments are very evolving, but it's very critical there is enough research happens and assessments in place to ensure these considerations, what I spoke about in last few minutes, are also kind of taken care. External reviews and accountabilities are addressed, limited availability of data is addressed, and mitigating the hidden biases, balancing the fairness and accuracy are kind of taken care. So essentially, one, as I said, artificial intelligence application in autonomous systems for me is already a very, very well researched and a field that is matured enough. However, is maturing even more faster and not really in a position to predict what will happen even 6 months from now or 1 year from now. And all the different components. There is a lot of use cases like autonomous vehicles, drone tech, health tech, and even simple things that is there in your home as geysers and refrigerators and your Android phones, from where you can really learn from what is the building blocks and how autonomous systems are evolving. And as it evolves, there is a lot of need for ethical, need for sustainable, maintainable, explainable algorithms, explainable frameworks that need to be there to get the success of AI-driven autonomous systems for human welfare. And I believe with today's session, you get sparked with some of these elements that kind of makes you curious to go and learn more on some of it or one of the topic and contribute to this journey. So with that, I thank you for this opportunity, and I hope my last 90 minutes was helpful for you. Thank you.
Thank you, sir. Really, your session was interactive and informative for the participants. You are talking about what is autonomous system, types of autonomous system, and applications of autonomous system. The real-world examples shared during the session were particularly valuable, sparking interest for the participants to do the research in this area. Overall, the session was highly informative. Thank you so much for spending your valuable time with us. Dear participants, now it's a time to interact with our resource person. If you have any questions, post your queries in the chat window, please. Yes, participants, if you have any queries, you can post your queries in the chat window so that sir will address your queries. Yes, somebody's raised your hand, I think so, middle of the session. Lavanya, do you have any queries? Please post your queries on the chat window, please.
Yeah, that's a good question, Sureja. Yes, one of the challenge with all the evolving tech is the shelf life of the tech. However, what you see is the underlying foundational algorithms, right? The CNN and ML and computer vision, what you studied or what some professors would have studied 10 years back are also relevant today and tomorrow. So if you're really starting to pursue a PhD, then what I would suggest is pick up one of the real life problem that is today faced by an industry or a humankind and see how the existing tech, and that is also evolving, can address it, building upon the research already done in that area, right? Purpose focused research, I believe, is far more beneficial, and that will also kind of keep you to contribute something new, leveraging the underlying tech, leveraging the underlying concepts to a solution. I hope that answers your question.
Yes, participants, do you have any other queries? Can post your queries in the chat window. Okay, I think they don't have any queries. With this, now I request Ms. Professor Priyanka Madam to conclude this session. Over to you, Priyanka Madam.
Yeah, thank you so much, sir. So I extend my profound gratitude to Mr. Gopalakrishnan S. Your deep expertise and articulate elucidation of this transformative technology provided invaluable perspectives, enriching our understanding of its vast potential, sir. So we sincerely appreciate your time, effort, and intellectual generosity in sharing your knowledge with us. Thank you so much, sir, once again for being with us today.
Thank you. It's my pleasure.
Thank you, sir.
Thank you, sir.
Thank you.
Yeah, the next resource person already joined the session. Today we are privileged to have another eminent industry expert, Dr. Selvaraj Keshavan from DXC Technology, Bangalore. Will be delivering a session on AI fundamentals, building blocks for the future. With his busy schedule, he accepted our invitation to deliver for today's session. With that, now I request Professor Priyanka Madam to introduce our resource person. Over to you, Priyanka Madam.
Thank you, Dr. Ashwin sir. Good evening, everyone. It is with great pleasure that I introduced our distinguished speaker for today's session, Dr. Selvaraj Keshavan, a highly accomplished technology architect and technical delivery leader with extensive expertise in embedded systems, IoT, edge computing, cloud, AI/ML, and digital transformation. Dr. Keshavan brings over 2 decades of experience in the technology industry, having excelled in roles such as practice lead, technology architect, solution consultant, and pre-sales advisor. His deep technical acumen and leadership skills have significantly contributed to the success of various organizations. He is currently a senior technology architect at DXC Technology, Bangalore, where he drives innovation and technical delivery in smart systems, connected devices, and cloud native applications. Coming to his professional journey, Dr. Keshavan has worked with some of the top global technology firms, which includes DXC Technology as a senior technology architect, and he has worked secondly in Accenture India as a technical architect. Then he has worked in AICTE Technologies as a technical leader, LG Soft India as a software engineer, at Sri Krishna College of Engineering and Technology as a senior lecturer. Throughout his career, he has led high-impact digital transformation projects across diverse industries, including automotive, manufacturing, healthcare, consumer electronics, smart cities, and fintech. Coming to his technical expertise and research, Dr. Keshavan is a TOGAF and AWS certified architect with hands-on experience in system design, IoT, cloud computing, AI/ML, and DevOps. His expertise spans software architecture, embedded middleware, real-time operating systems, mobile application development, and system integration. A strong advocate of innovation and research, Dr. Keshavan has published over 25 research papers in renowned journals and conferences. His PhD in media streaming rate adaptation from Karunya University, Tamil Nadu, reflects his deep expertise in real-time systems and multimedia technologies. Coming to his academic contributions and thought leadership, beyond his industry contributions, Dr. Keshavan is deeply passionate about mentoring, research, and knowledge sharing. He actively participates in FDPs, hackathons, and technical workshops. He has been instrumental in guiding students, researchers, and professionals in emerging fields like Industry 4.0, cloud computing, and AI-driven automation. Today, we have the privilege of learning from his vast experience and insights into a cutting-edge technology shaping the future of AI and digital transformation. Please join with me in extending a warm welcome to Dr. Selvaraj Keshavan, who would be discussing on the topic of AI fundamental building blocks for the future. We welcome you, sir.
Thank you, madam. Thanks for the introduction. Hope I'm audible. Screen visible, right?
Yes, sir, it is visible.
Okay. Okay. So, all right. Yeah. Thanks for joining. So today we'll talk about AI fundamentals, right? Right from building blocks for the future, and we'll quickly touch upon generative AI as well. Right? Okay. So what we are going to cover today. So we are going to cover, this is the key agenda points for the today's session. So we'll talk about introduction. So mainly talk about what is AI and how the AI terminology comes into picture. Then components of AI. Then post that how we can apply AI, right? So there are 3 components. You have the data, right? And you have to process and bring insights. So we are going to cover. They will touch upon generative AI concepts. Then we'll talk about explainable and responsible AI. So what do you mean by explainable and responsive AI? Finally, if time permits, we'll go through the case study as well. Okay. So let me start with the introduction. So hope you all might have read in your curriculum or textbooks. So artificial intelligence, right? It's again, I mean, a lot of buzzwords nowadays. We'll talk about artificial intelligence, machine learning, then deep learning, computer vision, right? Then cognitive intelligence, generative AI. There are a lot of buzzwords. So to begin with, let us understand what is artificial intelligence. Okay, so if you look at people's everyday life, people started using the product of artificial intelligence, right? From your chatbots, right? Or in social media, you have the image tagging, right? Or smart cars and also connected homes, right? So basically, AI is nothing but so how you want to make the machines to mimic like a human being. Okay, so if I want to do something the same way, I want to train the machine to do the same thing, right? For example, if I go in a car, the moment I see the speed breaker, I start applying a brake, right? If you make that machines to do the same thing, then that will become the artificial intelligence. Okay. So similarly, in your class, there are a number of students. If you ask someone, then they will tell who all will get above 90%, right? So most probably you'll be able to tell because of earlier historic data. The same thing, if I want to make my machine to tell the same thing, then that will become the machine learning and artificial intelligence. Right. So it is again how you simulate human intelligence in machines that are programmed. Basically, you have the machine, raw machine, right? That doesn't know anything. You program to think, then learn and perform tasks that typically require human intelligence. Okay. So again, if you think how we can create systems capable of performing tasks, like you have reasoning tasks, right, or problem solving, understanding natural languages, they're recognizing patterns and making decisions. For example, if I know some languages, if somebody speaks, I can interpret and understand the context. Similarly, if I want to make the machines to do that, then that will become the artificial intelligence. Okay. So there are multiple definitions for the artificial intelligence. So we can talk about systems that think like a humans. Typical example of voice chatbot, correct? So the moment you ask something, it will basically respond back like a human, right? Then again, systems that act like a humans. So and systems that think rationally, systems that act rationally. For example, if you have the robot or autonomous system, so that will also act like a rationally. I was talking about speed breaker example. Similar way, in autonomous vehicle, there are a lot of programming that has been done. So it will act like a human because it sends from the multiple sensors, collect the data, it acts immediately in real time. Okay. So altogether, we can say artificial intelligence is nothing but a machine who thinks and act like a human. So which act like a human, then think rationally and act rationally. Okay. So if you think this AI concepts are there long ago, so maybe some, if you look at, 40, 50 years, the people talking about AI, right? Even in my college days, we used to talk about neural network. Okay. So we keep talking about image recognition, character recognition. So that's how this AI is there still very long time. Okay. So how this AI concepts derived? So for example, if I want to design a system who should act like a human, behave like a human. So where this concept comes from? So basically, it comes from philosophy, right? It talks about the human consciousness and other things. Similarly, psychology, where it can how human think, what is a human perception, how a human react to the emotions, other things. Similarly, economics, we will talk about optimization and resource allocation. Similarly, neuroscience, how our our brain works, right? The same way we have to do that. Similarly, linguistics, right? The art of understanding the languages. So AI basically picked up concepts from everything, and all these concepts are picked up. And how, on the other side, we are applying. We are applying the mathematics. So there is something. So how I can take all these concepts, apply mathematics, right? Similarly, data science. So you have vast amount of data. So how we can get the data, clean the data, and apply some algorithms. Similarly, software engineering. So how I can utilize all the software engineering concept, right, from the software framework or hardware, right, the GPU, TPU, and other things. Similarly, architecture. So architecture in the sense then you CPU architecture, GPU, the TPU. So how I can utilize all these things to pick up the concepts from this and make my machine to behave like a human, right? So that's how this AI deeply intervened with various disciplines. I was talking about this, correct? Again, each tool and knowledge that guide the development of intelligent systems. So basically, we use multiple tools, multiple concepts. Finally, we have to make sure that our system should behave like intelligent systems. Okay, so the system should be able to identify or learn, continuously interact, understand the real world around them. Okay. So again, by getting the insights from all these areas, the researchers can create a system that functions more like a human intelligence I was talking about, making them useful in wide range of real world applications. So if you look at, there are enormous real world applications. So for each and everything will behave differently, right? Either it can be derived from reasoning, or derived from learning, right? Or derived from interacting. So that's how these researchers make the system capable of doing this. Okay. So I was talking about components, the key components of AI system. That includes, there are 6 main components that include from learning. Okay, so learning means, so how the system or the hardware or what you call the machine can mimic the human knowledge. Okay, so if you look at that can be derived from mathematics and neuroscience, right? You can pick up the concepts from neuroscience and apply some mathematical concepts and make sure that it keep continuously learning. Similarly, if you go for the reasoning, so reasoning is nothing but make decisions and conclusions. Okay, so that basically comes from the concept of philosophy and apply some algorithms from the mathematics. Right. Similarly, problem solving, so define search and solutions for the complex problems. If there are some complex issues or problems, how the AI can solve, that picks up concept from mathematics and economics, problem solving. Similarly, perception. So how do I interpret and understand the sensory input? For example, you can look at the autonomous vehicle where it goes. It picks up the images from the camera or picks up the data from the sensor and how it can understand and act, right? So that basically comes from neuroscience, right, and the psychology. Similarly, knowledge representation. So if there are a lot of knowledges, right, then how our brain basically stores or represents. If you can mimic the same kind of representation, that will become the knowledge representation, correct? So yeah, there are, you might have seen, there are a lot of ways to represent this knowledge. For example, in your Facebook, if you look at, they represent knowledge, right? There's a parent, there is a child, right? So one guy is how he is related to other guy. That's how they represent in the Facebook. Similar way, in AI also, there are some databases are available like Full Party and all. So it basically talks about ontology. So it is a concept in philosophy and how the knowledge can be represented. Again, language understanding. So it's the ability to interpret and process and generate human language. So when I talk something, it should be able to understand, come back, understand the entity, right? And basically we can derive the context, right? It picks up the concept from linguistics and psychology. Okay. So for example, typical example of real world, I thought I can give some real world example here. For example, learning, correct? So in case of learning, what's a typical example that we can give? Okay. So for example, if you have some medical image machining, which is AI enabled, so it basically learn from the scan. So the moment it scans, then automatically it can identify if there are any diseases, correct? So maybe it can, the machine itself equipped with a trained AI model already running. It can basically, the moment you give feed the new data or images, it can easily analyze and find out is there any disease, correct? So if you look at the real world device that is existing, you can see this Zebra medical vision device already AI enabled medical imaging machine, correct? So again, reasoning and decision making. So we are talking about how basically you can interpret, right, and get the image or data and make real-time decision. and navigate through the complex scenarios. For example, if autonomous vehicle, there is no driver, if just keep going traffic, keeps going the road, it has to sense the people, it has to sense the traffic, it has to look at the road, speed breaker, everything. It should be able to take decision in real time. Okay. So typical example, you can see the Tesla autopilot. Similarly, problem solving. So, how basically most efficient way that we can manage resources and reduce costs, right? So there are multiple things called route optimization. If you think about the navigation, correct, Uber or Ola, so it will basically look at the most efficient routes. It may look at the traffic, or it may look at any packages. Accordingly, it will easily reroute or manage resources. Similarly, perception. So perception, you can talk about facial recognition or image recognition. So basically, if you use Google Lens and all, you must have known that we can look at the picture, take the picture, the camera, it can automatically understand and translate into text, correct? Similarly, Facebook social graph, these are some of the typical example for the perception component. And again, knowledge representation. So how exactly you represent the knowledge, the complex relationship between one entity to another entities, and for the better search results. Okay, so this is widely used in semantic search. I don't know, you must have heard about the semantic search or augmented search, where so basically all these data sources are steamed or indexed it. Then again, if you do the semantic search, it will automatically pick up the synonyms or related words. It will basically give you, right, the correct results. That's way how the social graph, right? So basically, if there are some friends, it will automatically tell, right, you're a third connect or second connect in Facebook and all. That's how they are stored, the knowledge representation. Or other example is IBM Watson, or you can look at the pool party. Yes, this we used some time back for the augmented search, where it uses ontology concepts. It can store all this latent things. Again, language understanding. So most of you might be using this device, right? Alexa. Am I audible?
Yes, sir, you're audible.
Yeah. So in language understanding, so you have the Alexa device, correct? So it's another example for cognitive intelligence. More than one AI techniques used here. So the moment you ask something, it will automatically understand your language, convert your speech to text, then extract the entity through NLP, NLU. Then it will understand the context. It will get back the content again, convert text to voice, right? So Alexa is the typical example for conversational agents. Okay. So now, so we are talking about all these concepts, but how do I realize? Right. So, for example, I want to apply something, or I want to develop some application. So, how do I? What's the required? What's the building blocks for that? So, next few slides we are going to talk about only these three parts. Okay. So, AI or ML is nothing but only these three parts. Correct. So,
Dr. Selvaraj Keshavan, sorry to interrupt. I think Vinay Ji has raised his hand.
So, yeah.
Vinay Ji, any queries you have?
Okay. So what we can do, we can note down all these queries. We'll discuss at the end. Otherwise, it will be right. So we'll come back to your queries. That will be better, right? I think by mistakenly raised the hand. So, so when you talk about AI, ML, or anything, so we are going to talk about only these three concepts. Okay. So if you talk about in broad level, so only these three, right? You have the data, and you are going to process the data. Finally, you are going to bring insights and actions. Correct. So each part there's a separate stream. For example, if you have the data, what are the different types of data? How do we collect the data? So what's the data pipeline, data engineering, right? How do we clean up, process it? This is second part. Third part is, so you have the data, clean up the data, is ready for generating something. So that's why you have to apply all these techniques to bring insights and actions. Okay, so we are going to see only these three parts. But if you look at underlying, so how it will be. So I cannot talk only theoretical, right? So if you want to realize all these three in practical, so how do we do that? So what is required? First thing is you should know about AI infrastructure. Okay, so AI infrastructure is nothing but, so when you talk about algorithm and bringing insights, right, predictive insights or distributive insights or anything, so you need to have the underlying infrastructure. Underlying infrastructure is nothing but the hardware and software, required hardware and software, correct? So earlier we were using CPU. Now there are a lot of GPU, TPU machines are coming up. So we have to use underlying infrastructure for that. So if you have infrastructure, what is next is apply algorithms. For example, if you want to do something, you have to see which kind of architecture you have to use and apply algorithms, correct? So on the top, so if you want everything to be ready, I want to build only applications. I don't want to do some research on the algorithms and all. I want to build only application. For example, I want to do the facial recognition, right? If you go on Python, you can just open and code it using this algorithm, which is already available. That's why there is a AI platform and services which abstracts what user or the applications application developers wants. So AI platform and services. We'll talk about that. What are the AI services and platforms? Finally, this is the use case that I want to develop. For example, I want to develop as a computer vision use cases or speech recognition or image generation or NLP use cases, natural language processing, or some autonomous navigation, or I want to process some information. Few use cases that I have listed. So obviously, this is the use case that I want to develop. So I don't want to make any changes in the algorithm, basic algorithm, or I don't want to reinvent the algorithm. I just use the platform and services. I can develop it, correct? So across the line, so you have security and privacy. That's very, very important. That's a separate stream where all the cut across all the layers, we need to take care of security and privacy, correct? And also we have to look at the compliance and regulations. We'll talk about that, what kind of compliance and regulation that we need to go through. Okay. See, in high level, if I ask, I want to develop application or any use cases, you should remember, oh, below that I need the architecture algorithm, then there will be a infrastructure, right, and AI platform and services. So if you look at all these corporate companies, there are companies doing only AI infrastructure. There are companies which talk about architecture and algorithms. There are many cloud providers, they do AI platforms and services. And there are some companies who develop, right, and give it to the end user applications and use cases. Okay, so again, this application and use cases, domain specific. I am in the manufacturing, I can develop manufacturing related use cases, right, in retail or insurance, anything that I can develop. Okay. So, so we are talking about this. I thought of giving some practical examples of what it is. Okay. So if you talk about, we'll start from the AI infrastructure. Okay. So most of you might be knowing that's GPU machines are coming up with high processing or specialized processors. Correct. So you must have read sometime back that NVIDIA is the leader in this space because they are doing a lot of GPUs, right, and advanced AI GPUs. So if you look at NVIDIA A100 and all, it's advanced GPU specialized for the AI, correct? That's infrastructure. So why do you want a GPU? So why don't we go with CPU, right? So if you run all these models, GPU, it's very high performance. You can get that done quickly, right? Compared to CPU, which takes a lot of cycles, right, to basically execute any simple operations, correct? Similarly, you have AMD, right? And you can talk about Google specially designed TPU, tensor processing units as well, right? So apart from that, there are relevant other things also you should have been enhanced, right, from the memory, right, and where you store and other aspects. Other important area where there are a lot of research going on in the edge AI. Okay, so for example, if you collect something at the edge, so instead of sending to the platform or cloud, how do we handle it at the edge? Okay, so do I have the capable hardware at the edge? Can I get the inferences quickly in real time at the edge, right? Or you must have heard about this edge computing, fog computing, right? So you need a hardware. At the same time, it should not be a power hungry, and you should be able to run the model quickly and get inferences. That's why NVIDIA Jetson, they also come up with all this platform as well. NVIDIA Jetson, Intel, MoviDS. Okay. And typically we use a lot of software framework, right? Either, I mean, it's a TensorFlow, PyTorch, Keras. You must have used all this TensorFlow. These are all the software framework which runs on the top of the hardware, right? And if you have a lot of data to process, as I was talking about data, correct? So the data may be in a terabyte or more than that petabyte, okay? So how do we process and get insights? So you need kind of big data tools, big data processing. You must have heard about this Apache Spark, Hadoop are a typical example for the data processing, big data processing. Okay, and I need to store the data. So there are a lot of concepts, data lake, right, and transactional databases, analytics databases. So many are there, but typical example of databases, you can think about MongoDB, right, Cassandra. Similarly, data lake, you can talk about AWS data formation, Azure data lake, correct? And now I want some managed services. When I say managed services, so I don't want to do much thing, right? I don't want to set up a server. I don't want to manage my server for training my model, right? Validating my model. I want someone to provide all these things. I just type my code and I just want to train it or run it, correct? So I don't want to manage hardware. I don't want to manage any software framework, right? Or scaling, nothing. That's why you have a lot of managed services which cloud providers provide. So typically you must have heard about this Amazon SageMaker, Cloud AI, Google Cloud AI, Azure ML. So and AWS Bedrock is specialized for the Gen AI workloads, right? Amazon AWS Bedrock can easily deploy any Gen AI models. You can use any Gen AI models and build application quickly or agent quickly. So this one is for Prometheus for monitoring, right, or observability, I would say. So underlying infrastructure, there are cloud providers who provides without any services if you want. So I want to manage everything infrastructure, right? I want to put up a server. I want to manage everything. Then you can go ahead with infrastructure as a service from the cloud. Either you can use any one of the cloud providers, or you can do with your on-premises as well. So this is a typical example for AI infrastructure. And again, so I have all this infrastructure. Now I want to run, right? I want to run. I also have the data. So how do I run on top of this infrastructure, get my work done? So we can think about many algorithms. So I think I don't need to repeat this algorithm. You must have studied in many places. So you have conventional algorithms, machine learning algorithms, or deep learning algorithms like convolutional neural network, deep neural network, right? Then there are architecture. So even if you have algorithm, so you should have proper architecture, how the algorithm should run, correct? So there's a transformer architecture. This is mainly used in Gen AI. Similarly, HydraNet, I mean, it's again evolving, and even autonomous cars, Tesla clients, they're using this HydraNet also. So we can do the parallel task. For example, if you look at image segmentation, okay, so there will be a first thing when you see image segmentation, it will identify that's a human, right? Whether it's a vehicle, correct? But again, if the multiple human, how it will not be differentiate, right? That's why you have to go for a panoptic segmentation kind of things. If you want to do object detection plus panoptic segmentation together, so we can do this side and at the same timing and all. Similarly, Q-learning, you must have heard about this, right? It's a reinforcement model. So again, generative adversarial networks and autoencoder architecture, right? And also multi-agent systems. It's very familiar and it's evolving in the Gen AI space. And typical algorithms that we use to supervise, like a regression, linear regression, logical regression, then k-means and other things that come under category of this one. Okay. So now we are talking about both. So what I can do is, so I'm an application builder. Okay. So I don't want, I think, okay, so I have some problem statement. So I'm thinking that I have to use 2-3 algorithm and see how the result comes, correct? So I don't want to make any changes in the algorithm. So whatever the algorithm provides, I can use it. At most, I can do some hyperparameter tuning, correct? And do the comparison. So either you have comparison parameters, see which one fits for this, correct? Then what I can do is I don't want to directly run this algorithm, and on the top of that I can build the application, right? There is somebody who already have the library or built on it, so I can directly use. That's why we use platform and services. If you use SageMaker, it's up to you. You can use any algorithm, just call this library, train it, do that. Similarly, recognition, it is for the recognition for the NLP. Comprehend for the NLP, recognition for the computer vision. Similarly, Azure, you have all the services, computer vision, cognitive, then Google Cloud, right? Then if you want to use, do something on the GenAI side, there are available. You can use OpenAI, all this ChatGPT one, OpenAI APIs, you can directly do that. Similarly, if you want to do something on the edge side, so you can use NVIDIA Jetson. So I'm not listing all the components, a few examples. Okay. And again, coming to the compliance and regulatory part, so whatever we do, it should be compliant. For example, there is some medical application that you are trying to do. Okay, so if you do something, you should adhere to the HIPAA and FDA standard, correct? So that data privacy should not be exposed beyond some region, or the privacy, all this should be masked, right? So all those things should be taken care of. Similarly, GDPR, you know this, it's a European data privacy. Similarly, there are a few more compliance regulatory that's evolving. Even there's IEEE group that's also evolving. Apart from this, there's general information security management, we should adhere it, correct? Similarly, for autonomous vehicle, there is some standard that's coming up. So there are a few more standards. So it depends on which application and which domain that you are trying to build and which country. So accordingly, you have to follow this compliance and regulatory. Okay. So hope I'm clear till now. So after this, we will talk about the data processing and the insights. Okay. So now we understood basically what is AI and what's the fundamental components and blocks of AI. Now we can look at how we can apply that, correct, in day-to-day or real world scenario. Okay. So first thing that we need is data. So without data, there is no cloud, there is no AI, ML, there is no big data processing, nothing. Okay. So the core part is data, correct. So the reason that it's evolving, right? The AML evolving, even though it's existing 2 decades, 3 decades before of the data only. So now we can get more data. So how do we get more data? So because of IoT and other sensors, right? We are getting. So then again, even though AML concepts there, so earlier people use supercomputers and all, right? So not everybody will get access. Now, because of cloud comes, everybody get access. Okay, so whatever you want to do, you can do it. You can just configure it, run it, then decommission it. That is how it's all evolved. All are interconnected. Your cloud, your IoT, then AML, everything is interconnected. Correct. So data mostly we collect from all these sources. Okay, industrial system. So half of the data that comes from IoT sensors and devices. Even if you look at your mobile, there are numerous sensors that use a lot of data, correct, including your from GPS, accelerometer, gyroscope, and everything. Similarly, we get the data from social network, e-commerce, computation simulations, right, and industrial system. Then there will be some cyber security system. So nowadays, most of the data that also comes from the social network. Then to understand the people mindset, what they like, what they don't like. So simply capture the data and analyze it, right? So that we will easily identify what they like, what they don't like, or which one they prefer more. Okay. So even if you go to retail, if you go to Flipkart or Amazon, they will basically analyze your behavior, purchasing pattern. Based on that, they will also recommend, right? If there are a new product similar to your wish, they will recommend it. Okay. So a lot of data that has to be captured. So we have a lot of data. It depends on the application. So who's the source of the data? Then we have to collect it. Okay. So again, when I get a lot of data from sensors, devices, social network, ideally there are a lot of data, right? Especially in the IoT sensors and other things. So the data may be high velocity, variety, so many variant of the data, then high volume. So now I have so much of data, and some are structured, some are semi-structured, text, some junk data, everything comes together. So now I want to do something. So I have this, I mean, lot of data that comes in. So what will I do with that? So it depends on the business. So I'm thinking, so I'm collecting all this data. So can I get some streaming analysis and insights? Is that possible? Yes. So on the fly, is it possible to get some real-time analysis? And when the data comes, immediately you can see anything that goes on, I mean, any anomaly or outlier or anything that I can derive from the data. Okay. So otherwise, can I derive some meaningful KPIs saying that how is the behavior of this machine last 1 week? Or is this machine running? What is the efficiency of the machine? Or what is the overall equipment efficiency? Can I derive from the data? Yes, it is possible for the industrial application, right? And again, can I do some predictive? So is there a motor that keep running? So I don't want that motor to go. I mean, I don't want that motor shut down and entire operation will go for a toss, correct? So I don't want that to happen. So how do I predict whether the motor is going to fail or what is the remaining useful life of the motor? Is it possible? Yes, it is possible from the data that we are getting from the motor. Correct. So other way, can I use this? Can I bring the data, put it in the visualization and see what is going on, so that I can look at what is going on, whether I can control, operate, right? I can get the report, or quality inspection, or automate the process, right? Or in healthcare, can I do something from the data to improve the quality of life? Okay, so anything that I can use it for the research and improvement, everything is possible. Correct. But ideally, the question comes: how do we do that? I have the data, so how do I do that? So one first thing is you have to look at the data and see how good the data it is. Okay, so then only we can process. The next step is to process, correct? So there will be some junk data, there will be some null data, there will be a lot of data which is irrelevant. So first thing is we have to just process the data and see how the data is good. Only take some good data from the quality data, correct? So again, the data may be very huge, so we need to store in large repositories and complex analysis techniques. And most of the time it should be distributed processing, not one computer that can do. So we need to spin a lot of systems, distributed systems, and analyze it to finally bring the result back. Correct. Similarly, we should have databases like data lake, warehousing, and other things. Okay. So now I come here. So yeah, so one, you have the data. So now basically we need to know how I can collect the data, correct? And how I can process the data. Then post processing, definitely I can bring some insights, actions which is relevant to the industry, right? Industry or the one that you want, either which industry that you want, what kind of insights. Okay. So now we must have heard about these two things: data engineering and data science. Okay. So data engineering, nothing but how do you collect, transform, and manage the data. So, for example, if you want to collect some data, that may be the scale of 1 to 10. Other data might be scale of 1 to 100, correct? So you need to transform in the same level. Okay, so that then only you can process it, get the meaningful thing. That's the reason there will be ETL tool, and ETL tool does a lot, but I just gave small example so that it can transform the data how you want it, right, for that thing. So again, this pipeline, you have design, construction, and maintenance of the system. You collect the data. How do you collect, correct? And how do you store, and how do you clean up? So what are the tools that you'll use? Everything comes into data engineering pipeline. Data science is nothing but you have the data, but how do you analyze this data? It's not about collecting, storing, managing the data, but how do you analyze? What kind of algorithms, logic that you use to process, analyze, and extract some information into this. Okay, so even all these things will come into data science. Okay, so you must have studied about data mining also, right? Data mining also comes as part of this data science. Okay. So how do you do that? You use statistical approaches or use any kind of algorithm. So you do dimensionality reduction or whatever. So basically you have to process it. Okay. So collection, something like this. I just put some small diagram which talks about in IoT side, how do you collect the data? You have industrial equipment, you have multiple sensors attached, get all this parameter, go with edge gateway. So here where we can do the edge computing and all when you have the data. Then it basically stream the data to the cloud side. So basically you will have some IoT endpoint in the cloud. IoT platform, so where it can stream. Then finally, you have the streaming platform. So Mr. Heard about Apache, Kafka, or Kinesis kind of things, streaming platform. Finally, it gets to data lake. Then you can do the transformation and other things. Okay. So this is a small example of the flow, how the data comes here. Then storage wise, you already talked about the storage. So I can quickly go through. So I mean, who are working or who are taking this DBMS, they must be knowing. You have the relational databases, you have non-relational databases, correct? And again, non-relational, it's quite popular now. You have the key value, right? Graph databases, right? Object, many databases. Relational mainly talk about all this SQL structure, right? So again, we have to store large amount of data, and real-time streaming data should be stored and scalable, reliable in the sense the storage should be scalable. It's not like vertical scaling, right? So if you have configured 100 GB, once it's over, then you should shut down and you can configure another memory. That should not happen. So it should be horizontally scalable, and it should be multi-tenancy, and cost also matters. Okay. And I was talking about relational, non-relational databases. Like you can think about MongoDB. It's a document-based database. You have Redis, is widely used as a cache also, right, in memory, right, key value. And Redshift, correct, it's for the analytics. You have Cassandra, columnar database, HBase, DynamoDB in the AWS side. So it stores JSON, correct, and GraphDB. Okay, this I'm just giving example who are not heard this. I mean, can also just go through this. So for any requirement, you can think this kind of database is already available. Right? There are some as a specific to some cloud platform, some are available as a we can also install it wherever on-premises or cloud. So now I was talking about data and processing, but anyway, data quality is very, very important. As first step is to look at the data and see what is missing. Is there any noise, any artifact, any outliers, any missing values, any duplicate data, any wrong data? So these are the things we should look at and remove it. So if you process without removing this, obviously we don't get the expected result. Okay, the result may go wrong or the pattern may not be proper. That's why we have to apply some techniques and see how we can remove all these things. So before that also we should understand about the data, correct? To remove this, is that something distributed properly? You might have heard about this distribution, right? Binomial distribution or centered about the value. So all those things are very important to understand the data. Correct. And here only we to remove all these things, we apply all this statistical algorithms or approaches for the data processing. Okay. So if you look at here we do, and there are some example techniques that we use it for all the data processing, right from data exploration. You all know there will be a chart kind of histogram chart, when we can look at how the data looks like. Okay, so some of the issues that we can find out from the EDA only, exploratory data analysis, and how it is distributed. Is that centered about some mean, or what's the variance, what's the standard deviation? So these are all things that typically we use for the EDA. Okay, and the data cleaning. So we can also look at all these things. How do you detect the outlier, right? You have IQR, you have immediate transformation. All those things you can apply here. So missing value. So how do you missing value? There are some value which is missing, but which is significant. How do I get that value, right? And similarly, univariate, bivariate, all these things can be applied. Again, data integration. So you need to know how to integrate. Okay, so if there are multiple databases, files, how do you integrate it? Is the connector available? So how do we transform? I was talking about ETL, correct? So similarly, here also you can see all those things, right? Data transformation. Is that something 1 to 10 scale? How do we make it 1 to 100? Right? Is that simple multiplication, or get it like logarithmic or square root, something like that we can think about. Finally, there are so much of data available. Okay, gigabyte of data. Most of the time, it's we don't need to take all the data. So we need to see what are the key parameters, and we have to take that. For example, sometimes you collect the data which has thousands of parameters, but most of the parameters are not significant, which will not give you the randomness. Okay, so anything that gives randomness, which gives the more value. Okay, it's like our cricket, right? If you are not able to predict, then we'll get the more value. That's why some information is constant, right, and static, so which will not be useful. So we can remove. So how do I remove? So how do I understand first the data and remove? So we can use principal component analysis approach, or correlation, or variable clustering. So that's how we can reduce the dimensionality. So why do you want to reduce? Because more stagnant data, and also so we need to spend a lot of cost on the data processing if we don't reduce it. Okay. So some of the things we already talked about, so I don't want to talk how you process it, other things, all this already there. So we can talk about Informatica Talent, which are ETL tools. I was talking about Kafka for the event processing, Splunk, right, and other things. Similarly, how do you do this? Okay, so I was talking. We are not talking about AI/ML models, right? Before that, if you want to clean the data, process the data, how do you do that? So same thing we can apply here as well. So you can use all your Python, Jupyter Notebook kind of IDE, do that, or R programming, other things like you can use TensorFlow framework, right, or Spark, MLib. This way we can do this, correct? So now the question comes, where do we store? Where do you install big data tools? Who is providing process computing, right? Who is providing computing, memory, storage, and network capabilities to do all these things? That's why this cloud comes into picture, where you can leverage. Earlier, it is on premises, it's very difficult to buy. Okay, so it's a huge capex, capital expenses, and it's very hard to buy. That's why now cloud comes into picture. That's why most of the people use and do all these things. Okay. So now we come back to insights. Now you have the data, so you know how to clean the data, right? And you also know how to collect, store the data. Now the data is ready, right? But now we can use for our real-time application. So how do I use this data? Get some insights. Okay. So how do I use? Simply I can do something and I can get the insights, correct? I can query. So if the data is stored in the databases, or simply I can do SQL query saying that what is the last 1 week trend, what is the last 1 month trend, obviously it will give. I can show it in either Power BI or Angular, any front-end tools. Correct. That's one option. So other option is that how do I get predictive, correct? Or how do I get anomaly? Is there anything I can do? Or how do I get content generated? So I have some data. So I want to generate some new content out of this data, maybe future content, or I have vast amount of content. I need to get something. Okay. You can think that you have given some thousands of research article, right? And now you are asking, give me the literature survey of neural network, correct? Neural network. It obviously, if you train that model, it will obviously give. So give me the latest research survey, 2024 research survey of neural network. It obviously give, correct? You can ask 10, 20. If you have trained the model with all the research paper, obviously it will pick up and give, correct? So now we have so much of data. So now we have to generate insights and action. It's up to us. How do we want to generate insights, and where do we need? How do we use that? Okay. So now I have data ready for analysis. Then I need all this, correct? So I need some analytics. Oh, I need to do some descriptive task. I need to do predictive task. Oh, I want to generate some content. So now we have to work this part. Okay. So you have to put the data. So what we are going to do here, finally, we are getting outcome. Correct. So that's why we are going to look at our AI, ML, right? All this Gen AI here. Okay. So before that, I hope you will understand descriptive task, predictive task. Descriptive is nothing but how basically clustering, right? Clustering is again a descriptive human interpretable pattern. It will give you. Similarly, association rule analytics. Hope you may be knowing like a priori algorithm or a priori algorithm. So I forgot. Similarly, anomaly detection. These are all the examples for descriptive, right? Similarly, predictive. You can talk about regression classification, correct? So so whether the particular thing is spam or not, binary classification or multi-class classification, right? Similarly, regression, predicting something, all these things will come into predictive. Similarly, content generation, this is very familiar nowadays. We all use this ChatGPT and the other things. How do we generate the content, new content from the old data? Okay, so that's why you have this text you can generate, audio, right? Music, image, video, all this that we can generate it. That's why we do something based on our need, so that we will get all these things, whatever we need it. Okay, so simple, small. Hope we have enough time. Okay, so so before we move into that, so I want you guys to understand machine learning, difference between machine learning or what is artificial intelligence in a layman terms, and what is cognitive intelligence. Yeah, people keep using different words interchangeably, correct? So machine learning is nothing but make machines to react like a human or learn like a human. That's all. Okay. For example, I want to predict the outcome of the particular section, what's the result of the particular exam, correct? Then it can tell you, oh, this is the historical data that you already given to me. I trained, so that when I feed the student's name or whatever, a list of students, it will automatically tell, okay, some 10 people will get above 90, then below 90 or whatever, correct? That's the machine learning. Make machines to learn like a human, right? You have the clean data, you are giving historical data and make machines to learn. That's all. Okay, so I'm not going through the complete thing, but where we use this machine learning, we can use predictions, recommendations of product prices, estimating time, and everywhere we can use machine learning. So when I talk about machine learning, so you should know what is artificial intelligence, right? This is also same stream. Okay, so artificial intelligence is nothing but make machines to learn and take action. Okay, I was talking about the autonomous vehicle. The moment you make machines to learn that, oh, there is a speed breaker, right? Then immediately, if the system itself applies a speed, brake, then that will become the artificial intelligence. That's all. Okay. It basically, we have programmed that program's ability to learn from the historical data, and the moment we give the new data, it understands and also to control. Okay. So for everything, data mining is also the foundation. Okay. Then what is deep learning? Okay. It's the one level down where machine learning is in generic. So if you want deep learn, for example, facial recognition. So if the face is in some shape or whatever, this machine learning is able to predict, correct, or able to identify. If the face is in different directions, still you want to find out, you go with the deep learning. So the deep learning behaves like a human brain, where you have all the neural network comes into picture, and it should be able to train and get the result out, right? So again, it is more for the excellent performance in the big data sets. Okay, and again, depends on multiple layers. It automatically the performance accuracy also improves. In computer vision subset, where it deals only with image and video. So where how do you identify objects? How do you extract information from the audio, video, right? And the textures, edges, all those things will apply this computer vision. Now comes into picture of cognitive intelligence. People talk about cognitive intelligence, nothing but we are using more than one branch of AI. Okay, then that will become the cognitive intelligence. For example, autonomous vehicle. Okay, so autonomous vehicle, if you are able to control, stop, start, all those things, what it can do is it can use NLP and the machine learning, right? That will become the cognitive intelligence system. Similarly, if you have content AI, for example, Alexa, Google Home, it's basically you are asking Alexa, Google Home to do something, and it will also know your personalization, correct? It can store recommendation, all those things. That's why it will become the cognitive intelligence. Similarly, smart IoT devices, where it can give the data and it's be able to control using edge and fog thing. Okay. So nothing to confuse. Maybe you can think cognitive intelligence nothing but it's using more than one branches of artificial intelligence or techniques and come up with the final product. Okay. So this is a typical example where we use conventional AI, where you have supervised and unsupervised reinforcement. So yeah, so these are some of the algorithm. Supervised means, so we have the label. Using that label historical data we train, then when we get the label data, again it will be able to find out, correct? So unsupervised is not labeled data, so I have no idea classify, but algorithm should classify and come up with some pattern, right? You can think of k-means, autoencoders, right? I mean, either conventional or neural network-based algorithms that we can use it here. We can use it here also. Again, reinforcement learning, so where we use reward-based reward and punishments, correct? So yeah, this is quite good area and a lot of research going on. Who are doing research, most of the people are started working on reinforcement learning. So how we can apply reinforcement learning and come up with use cases and solve some problems, correct? Typical example of you have the chess game, right? That uses reinforcement learning. Algorithm like Q learning, right? A deep Q network or all this PPO, right? Proximal policy optimization are the some of the examples of reinforcement learning algorithms. Okay. So now, so I hope you understand the difference between all these things. Three, at least. You have the artificial intelligence, you know what it is. Okay. Then below that, you know, machine learning, make machines to learn. Then if you take may learn and action, it will become like kind of human brain, right? Artificial intelligence. Deep learning again subset where multi-layered behaves like a human brain. Now we come into generative AI. Okay, so now everybody started talking about generative AI, right? So why people talking about generative AI? It reduces our work. It gives what we want, correct? Again, generative AI is nothing but a pre-built model. Okay, so in conventional, what we do? So we use data to train, build the model. So that model we are going to deploy that. Then we give the real-time data, which gives the inferences or outcome, correct? But in generative AI, we are not going to do that part. So we are using the pre-trained model. So already somebody trained for us. Okay, so we are going to use only that model. We give input and get output. Okay, that will become the generative AI model. So generative AI model, there are some models, only language models where it can generate languages or text, right? Some models are multimodal, where it can use it for languages, or it can generate images, or it can generate video and other things. Okay. So hope you understand. Generative AI is nothing but already pre-trained model. We can call it as a foundational models. Okay. Okay. So this is how it goes. So foundation model is nothing but pre-trained model. Somebody does for us, example of ChatGPT or DeepSeek or whatever comes, correct? Or Gemini. So all this pre-trained model, correct? Say that it is hosted somewhere else, they give you APIs, or if possible, you have the enough infrastructure, you can also host it in your local, right? That's how this foundation model comes into picture. I am giving input, then foundation model trained to react to me because it trained with millions of parameters, correct? Millions of parameters, dictionary and other things. So it will automatically recognize and it knows what needs to be done, understand the context and where to get the information and how to react. That's why I am giving input, I'll also get output, correct? For example, I say that analyze financial performance of a company, okay, for XYZ company over past 5 years. Last 5 years. Okay, considering the market trend, competitive performance, and internal challenges, and provide an actionable recommendation for the growth. So what it will do? It knows the company. It knows. I mean, the company document already fed into that, right? It also knows all this competitor document fed into that. It knows who's leading or who is the competitor. It can automatically recognize and synthesize the data from various sources and perform analysis and generate strategic recommendation or KPIs automatically, correct? So that's why it gives and it can give you output, correct? Something like this. But if you are running a company, right, and it's very unique and you don't have any document available in public, similarly competitors, if you ask, definitely it cannot give because this model is not trained, correct? So that's why it's applicable for many use cases like text summarization, like question and answering, digital art creation, code generation, right? Then again, it reduces time cost to develop ML models. Okay, so I don't know whether you guys are aware. Now there are a lot of code generation done by the generative AI. Okay, so yeah, last week I attended AWS AI Conclave where they are demonstrating. So if you do some wireframe in a hand, okay. For example, if you want your mobile application to look like this, right? First page should be like some grid, and the moment you click some button, it should go here, right? It should look like this, and automatically it recognizes that file, okay, wireframe, it automatically generates the web application. So that's what they were showing in last day, AWS country. So what it will do over the period, all these application developers, instead of 4 or 5 developers, they need only one. So all other things will be taken care by the generative AI. Okay, so automatically generate, give you. So you can review and maybe update it. That's what it's getting. Also test cases, right? So yeah, there is a prediction that analysis report that they can see. So most of the test cases automatically it can be generated by the generative AI. So you don't need testers to look at the requirement, come up with the functional test cases and other things. It will automatically generate. So that's how it's automating and reducing the manual work, obviously. So we also learn the skill. Okay. So this is for the Gartner. It says 80% of the enterprises will have used generative AI APIs or deployed generative AI-enabled apps by 2026. Means in next year. So most of the 80% of the enterprises or companies definitely they will use AI, right? Either it is any domain specific or productivity improvement or for the customers they had to use. Okay, that's how the prediction. So everybody should know how to use this and how to build application from the generative AI. Okay. So again, so how generative AI helps? You can see it can significantly boost productivity, automating tasks. I was talking about test case generation. Now, if you look at agile world, so you need to have all this user story generated from the epics or the futures, correct? So nowadays, what we'll do, we as a team, we used to get into that and we had to come up with, discuss product owner, come up with user story, correct? Now there are tools, Gen AI based tools. If you give the requirement, it will automatically generate user stories. It will also give you the acceptance criteria. So like test case generation, I was talking about code, I was talking about, and UX design. So nowadays, if you look at many people use Adobe or Figma to do this UX design, correct? That also now generative AI does, and they will also come up with a very good UX design as well, correct? So again, more novel interactive ways to engage customers. Okay, so for example, engage customer in natural conversation, assist with queries, and provide tailored product recommendation. So even if you ask which is the product best for me, or which is a product coming up, so it will give you very good product recommendation because it understands you. So it has a lot of data within it. It can give you or the efficient way to interact Q&A. Right? So it gives. Okay. Again, healthcare, it can analyze, right? So basically analyze patient data, clinical records, and research to generate personalized treatment plans. For example, if you have a lot of data, right? So something called a drug recommendation. So it's not that fever means everybody should get that same tablet, correct? So it will analyze your behavior or your history, DNA or whatever. So it can analyze and it can also recommend specific drugs or treatment plan, correct? So again, including if you want to, so I don't know how many of you know there is a research. It started writing the research paper, right? Typeset or whatever. So it started writing research paper. If you give the proper prompt, it can give you similarly blog post, so social media captions, and it can create the video. There are some tools which is still not open source. But when we pay, then we can get all these options already available in the generative AI. Okay. So use case we already discussed, but few other use cases you can think about: chatbot, similarly contact center transformation. This is very, very important, right? In application management and all, where we can have this transformation. Similarly, ML ops that comes into picture where you have a lot of tickets that is raised, right? For example, in a larger organization, if you want a laptop, you have to raise it, or if you want to HR, you have to raise the ticket, right? Similarly, in application management, I am managing a big application. There are some incident comes from the customer, so that right now you have the L1 team, L2 team, L3 team. But if you apply this generative AI concept, it will automatically understand which is a ticket, it do the triage, it will automatically assign the person who already solved, right? Or it can pick up the knowledge document which is already solved and what is the solution. So those kind of automations already there in many organizations. It's coming up. Again, summarization, for example, I keep talking about last 1 hour or whatever. So is that possible to summarize it in 1 paragraph or whatever? It is possible with Gen AI. In the content creation, right? Data to insights, you have data and you want to get the insights, and document processing, process optimization. So everywhere we can use this. Okay. So I was talking about traditional model, which is foundational model. Right? So traditional model, this is what we do. So we have to train. Okay, so all this ML model we have to train, then we have to deploy it. The moment we deploy it, then we can give the real-time input, we'll get the output, correct? For example, I want to build the model for summarization, you train it in your machine or, cloud infrastructure. The moment you train with your historical data, you deploy it, correct? So then you expose the API or the interfaces, then you get the real-time data or prompt, then you give the output. That is how the real-time model works. What about foundation model? This is our foundation model. Okay. So somebody else training for us using thousands of GPU, okay, 2,000, 3,000 of GPU machines. They take the data, whatever available, right? Whatever appropriate, everything, then do all this processing. Then they train, they'll give you the pre-trained model. Okay. If you look at all this DeepSeek, they're saying they're using some 2,000 GPU machines, right? But it's quite less compared to in other guys like ChatGPT. Other people use more than that. I think these people did with 1,000th of cost. Correct. So what they do? So they also have some algorithm inside, like which parameter to take, which parameter not to take, not to take all the parameters. Right. Likewise, you have to train it. A company who provide this model, obviously they'll train it, then they'll host it, then they'll have multiple plans, right? It's like it's a generic model that I hosted. I can get only generic content, right? So other guy will say, no, there is some insurance guys want some insurance related results. So I train model, pre-train that model, giving more insurance relevant data. Then that's become the domain specific model, and it depends how they monetize. It can be a free or it can monetize the API usage and other things. You will get the relevant data. That's why these foundation models can be built. Either it can be generic or domain specific other things. So finally, we can just use adapt. That's all. So put that, you give the real time, you get the output. So here we don't train and we don't. We can get the pre-trained model to deploy, but we don't actually deploy it. Okay. So how we can train? Typical example, you have GB, terabyte, petabyte of unstructured data, correct? And you have to do all this tokens. This is what there is algorithm that you have to pick up the relevant tokens. This is where they DeepSeek did something. Okay, so they were able to do it with a minimal one and give it to the large language model. This is for language, but in general, you can give it to other models as well. Finally, you will get all these things, right? So I was talking about foundation model. So foundation model, it's already told, it's a large pre-trained AI models. Okay, then what is meant by pre-trained model? That's already trained on large general purpose data set. Okay, that's something called pre-trained model. So what is fine tuning? Now you might be thinking, oh, this already pre-trained, but it's not giving the proper data to me. So is that possible to train for me? Okay. For example, I work in a manufacturing. Okay, so when I ask some questions or when I ask some data, it's not giving because it does not know my data. Correct. There are some data which is not public. So this model has never seen my data, never used my data. That's how you can do with model fine tuning. So there's an approach for model fine tuning or retrain. Okay. So for example, I want to retrain. There's a possibility that you can retrain. So how you retrain? So there you locally also you can retrain, or you can use some APIs which are already available. You can retrain, but ensure that now they ensure that the data that you provide for retrain, so that should not be used for the other customers or other vendors. Okay. For example, I use some my own data, so my own enterprise database data and train it. Correct. If other companies accessing the same model, you should not reveal the data. Correct. That's how you have to retrain, and there's some SLAs, right? Or the providers basically will not allow others to use this pre-trained model or whatever. Again, some terminology of zero-shot learning, then few-shot learning. It can learn without anything, or it can learn with giving minimal data sets. Again, very important concept is prompt. So its prompt is nothing but how you instruct to get the data. Okay, so if you don't know how to use, then you will not get the relevant information, correct? You have to be very specific to get the exact or appropriate information. That's how this prompt engineering is very, very important. Okay. Again, this agent comes into picture. There is a single agent, multi-agent. If you look at nowadays in GenAI side, there are a lot of agent-based applications that comes into picture. It automatically know what to do, how to react, right, for the environment changes. Correct. Even I heard that there is a computer agent also comes into picture where it will also behave like you. Okay, so if you, even if you are not around, if your agent is running, it will do whatever you do. Correct. It will take the screenshot, learn, then automatically it will behave like you. Even if you are not there, it will automatically react. Correct. Then I was talking about large language model. So examples are your GPT-3, then BART, Jurassic. Similarly, image generation model, which is a GenAI model only for image. You can see that DALI is very, very familiar. Code generation, you have Copilot. I don't know how many of you use Copilot. It's already integrated with GitHub, correct? So Copilot, right, and Codex also. Similarly, multimodal. Multimodal in the sense it can work for text generation, it can work for image generation and other things. Flamingo, Whisper, Visual, Pet. Okay, there are so many models. Just capture few examples. Okay, so if you are interested, or if you want to do further research, or if you want to build some application on the top of that, it's very essential, mandatory to know the architecture as well. Correct. So architecture is very, very important. You have model, but how it works, either first you have to take input and parallel you have to process, or you have to process sequentially, right? That's something called architecture, right? So the architecture is very, very important, and I think people who get more efficiency or accuracy or cost reduction, they follow different architecture or combination of one or two architecture. Okay. So there are few architecture examples that I have given. Transformer-based architecture is very, very familiar, and most of the GenAI models using this transformer-based architecture, like you have PET model, correct, and you have GPT 1, I think 3, 4, 5, all those things are using. Similarly, variational autocaders, this is also very famous, correct. And diffusion models, similarly, recurrent and neural network models, some attention mechanism models. These are some examples, right? So architecture in the sense you use the model on the top of that, which architecture is basically running, right? This is foundation model. Here, if you look at, there are some foundation model and application, and what's the foundation model that is used, right? So it's everybody knows ChatGPT. So it's a generative pre-trained transformer. The transformer basically tells about the architecture, transformer architecture. Then GitHub Copilot. So if you want to code generation, or if you want to see anything that missing or code recommendation, you can go with Copilot. Nowadays, even there are models, right? There are foundation models which solves about security vulnerabilities. So if you write a code and if you run that security vulnerability test, right? So then what it will do, it will automatically identify, okay, this are security vulnerabilities and risk. Then if you give it to the GenAI, it will automatically fix. Okay. Then Google Gemini, then PicChat, then DALI 2. This is very, very important. This also follow this diffusion model architecture as well. DeepMind, okay, this is also famous. Then Google Assistant, OpenAI Codex, right? So you can think about, for some models, which basically multimodal, some models specific to something, right? Some models with this other names, so they also use different architecture as well. Okay. So now, what is underlying that you need to make it efficient, quite fast, get the real-time insights, and able to process big amount of data. Okay, so we cannot achieve alone with software, with the CPU. Okay, so we need a specialized hardware. That's why all this AI ML hardware organization investing heavily, including your AMD, NVIDIA, right? Intel also lagging, but they are also investing. Okay, then the reason why NVIDIA shares went down last week because of DeepSeek. The reason is DeepSeek claimed that they were able to do that with the minimal server setup, right? So maybe so that then the companies who were wants to retrain or train, and they may not go with big amount of server ordering, correct? So then obviously the business will go down. That's why you have to see this big business, the hardware. So you can think about a lot of GPUs. I mean, there are categories in that. So you may understand if you are familiar with the hardware. Yeah, there's a GPU, there is a TensorFlow unit, right? There is a neural processing unit, there is a FPGA, there is a ASIC, correct? So this all comes into hardware side. So there's a difference, slight difference between each one, ASIC, FPGA, GPU. But if you want to learn, just learn the differences so that, I mean, which one will be more costly, right? And which one will be very fast, all those things, correct? So here, if you look at the NVIDIA, and it's maybe this architecture. Similarly, so all this NLP, right? All similarly, TensorFlow unit, processing unit, develop custom hardware, specific AI tasks. So all companies are investing, and they are saying that it should be, for example, if you develop something on the TensorFlow, see how efficiently it can run quickly. That's why it just goes into picture. Correct. Our Intel also developed. So many companies are developing. These are some of the examples. Okay. So for example, in GPU category, so NVIDIA, right? They follow this architecture, and this is a performance. Okay. And similarly, other chipset. There is something called CUDA. I don't know how many of you know. This very famous framework which takes care of on the top of the hardware. In the neural processing unit, even UI, then Google developed, then tensor processing unit, ASIC, application specific integrated circuits. Okay, this is only once program. You cannot do that, but it will run very fast. Okay, similarly, field programmable gateway arrays like Xilinx, all these RF things. Okay, so that's also developed. So where we can use, it depends. Okay, so if you want to high performance and only one algorithm, it's always you flash it here, right? It will go fast, and mainly for the deep learning model training. Okay. Similarly, FPGA reprogrammable, ideal for real-time AI and edge computing. FPGA, correct? But the GPU in general optimized for all this software kind of programming. And there is another AMD MI300. It is CPU GPU functionality combined in a single chipset. So hope you are aware what is processor and chipset, right? So processor is like now if you look at Qualcomm Snapdragon, we keep talking, no, that's a chipset. Inside they use the ARM processor. So processor along with all the necessary units, then we'll call it as a chipset. Similarly, Intel chipset, we are using Intel chipset or Intel motherboard, which uses Intel processor along with all the necessary component, right? Okay, so now I was talking about domain training. So there are sometimes we may need to use this Gen AI specific to some domain. So I need to train. Okay, so how do I train? So if I have large infrastructure locally, yeah, I can use the existing pre-training model, put it inside. On the top of it, I can install TensorFlow, Hugging Face transformers, which will give you the access. Then I can give the data and train it. Or there is a possibility of using CUDA or so OpenAI itself providing some APIs, you can train it. So as I told, we need to be very careful when you are exposing some secure data. So it should be restricted, correct? So the providers should be able to tell, okay, this is your data will not be exposed, even this pre-trained model, or after you do domain training, that model will not be used by others, or your information will not be revealed outside. Okay. So now I want to talk about some industry challenges. So before we close, so one is since the industry is evolving day by day, we are getting new product, new technologies. First thing is you have to be staying competitive. So we need to keep go through and align with your business. So I want to do application business. So you look at which is good and do that. So I want to do developing some algorithms, optimizing development product. You have to be see which one is very feasible, compare and do that. So staying competitive is very, very important. And scaling in efficiency. Anything that you do, you should be able to scale it across. For example, if 1,000 users, 2,000 users, or millions of users using, then how do I scale it and also efficiently use? Okay. And again, nowadays more recommendation, personalization specific. For example, one insurance company using, then they'll also look at, okay, how personalized information that I will get specific to the users, right? And how do I give more customer experience? That's very, very important. Other thing is data privacy and security. Nowadays, if you look at very, very important, most of the time we expose the data, right? We'll get into legal issues. It's very, very important. You have to see how the data can be securely stored as well as privacy maintained, all those things. Again, to develop something as the new skills are coming up, new languages, framework, correct? It's very, very important. So you have to look at the organization, look at the skill gaps, resource limitation. Also see how we can integrate complexity, right? One system to another system, it's interoperable. Similarly, regulatory, ethical, product development, complexity, the whole challenges. Okay, so now we'll get into another very good area of explainable AI. So I don't know how many of some of you might be already doing some research on it. What is explainable AI? Okay, so you do something, you are getting output, correct? How do you know that is output is correct? Whether your algorithm is not biased, it's giving correct output. Okay, you do some skill training, right? Skill training, or you do recruitment for some military or whatever. So if you are trained with all the male data, obviously it is biased, correct? It will not give any proper data, I mean proper outcome for the females. So how do I know this particular model or the solution that I build, it is not biased? Okay, it should true, ethical, and it should not misuse or whatever, right? It should be clear, interpretable. I should be able to interpretable, saying that maintains for transparency, correct, and trustworthy. This is very, very important, and there are numerous research going on. If you want to do some research, better pick up this area. It's one of the very good area that can really do good work. Okay, so here we can divide into two parts. One is you can see white box models and black box models. Okay, so white box models means it's transparent, you know, correct? So for example, if I use decision tree, I always know, okay, this is a decision tree, this is a result. I can go back to the and reverse engineering and come back how the tree is allocated, correct? First, you might be seeing that two tree allocated, right? You can pick up two different things, and you can also see. That's how you can go back and look at. So in a linear regression, you can directly interpret coefficients, right? In a linear equation, you can look at coefficient, how it is getting generated, it's biased, or it is, I mean, correct. Or you can easily do the reverse engineering and understand the impact. For example, if I change the coefficient, what happens? Something like that, you can easily do that. That's kind of transparent models or white box models. Okay, so black box models, same opaque models, correct? So which is not transparent. So you don't know. You are giving input, you are getting output. You don't know what is happening inside. So you also don't have a control or look at what is happening inside, so that you will not be able to understand this model gives trustworthy, clear outcome, or it is biased, correct? So so internal decision making it will not give. So for example, in deep neural network or random forest or support vector machines, if you look at it, it's not transparent. You cannot do reverse engineering, see how it works, right? Because there will be multiplication, how it changes, on what basis it, the coefficient changes or weights changed. That we have to do a lot of things, right? It's very, very difficult. Okay, so that's how internal mechanisms are difficult to interpret. Then additional methods, basically how we want to interpret. That's something research, correct? So it's not possible to interpret. Is there something that I can do so that I can interpret the decision-making process of this particular models, black box models? Okay. So there are approaches. So I listed few, but if you are interested, you can do more research, and you can also get very good insights. Correct. So these are some approaches which basically helps in the black box model how I can understand the decision that's made by the black box, right? One is LIME, local interpretable model agnostic explanation. Okay, so basically what it does for some models, for example, if you take neural network model, it creates another interpretable model called linear regression, and basically tells how this basically behavior of the black box model. Okay, and again, Arun Sharp, I'm not going in depth, so I'm just giving heads up. So based on the game theory, okay, so it's basically it will tell you each feature. There are multiple features that is used, right, as input, and it will tell you each feature what is the weightage. correct? The model prediction. So one is should not be more biased or more weightage, another should not be treated, right? So you'll be able to find it out using this chart. Okay. So typical example, it is credit score. Okay. So for example, see credit score, right? If it is black box model, if you're using something, you may get less credit or more credit, but you'll not be able to know why, correct? That's so if the loan is denied, also you'll not be able to know, right, why it is denied. But when you use this, you'll be able to understand which feature basically constitute the denial of your loan from this, correct? Then there are some more approaches. Future importance, there's another approach where which features or input variables have most influence the model prediction. Similarly, surrogate models, so interpretable model that we can create using this approach. Then activation maps and saliency maps, here also you can tell. So now we can look at the literature or how what are the different models, right? How it basically helps to understand the black box interpretation and what are the limitations, right? And how we can improve it, so what's the efficiency. So there are a lot of work that we can do in this explainable AI. So another is responsible AI. What is responsible AI? If I am a responsible citizen, I should not do something, correct? So I should know how to behave in the public. I should know how to respect the mutual respect, right? I should not give any, harassing words or whatever, correct? So even if you train the model, it should behave like a responsible, like how we behave. Okay. So that's how you have to ensure. Otherwise, unnecessarily it can give some political statement which will get into issues, right? Or unnecessarily it can give some harassment statement or unethical words, right? Or unused words. That is not good. Okay. So that's why anything that you do, so you have to make sure it's a responsible AI. Like basically, there will be a while training, or if you use AWS Vector control, there is an option that what are things that you got to avoid, you should not speak. So we can configure it. Okay. So that even if you ask, it will not tell you. Okay. I don't know whether ChatGPT will give some political statement, but obviously it should not give. So they might have configured already. Similarly, fairness, considering impacts on different groups of stakeholders, right? Very fairness. Okay. For example, typical example, you have the hiring algorithm by company institutes. It does not disappropriately favor one gender or ethnicity by analyzing recruitment data for biases. That's it. It should be fairness, correct? It should be based on the parameters. It should not bias. Similarly, explainability, we were talking about explainable AI, same thing. Yeah, it should be able to explain. Controllability, so I should be able to control, correct? So even it should not avoid controlling. So there should be a manual override option. That's something, controllability should be there. Safety. So I was talking about, right? So it should not suggest harmful or inaccurate treatment to the patients, or it should not suggest some unused words or whatever. Privacy and security, it should basically tell which data that you can give, which data you should not do. So for example, if you ask a financial statement of specific people or healthcare data, it should not give. Similarly, governance. So basically, how we can use best practices into AI supply chain and including providers and deployers. That's why you do the governance. Example is given like a large e-commerce platform. It follows the industry standards. You should not give anything unindustry. You should follow the industry standards and regulations here. And transparency, so it should be very transparent. It's similar to explainable AI. Okay, so so again, how the data should be used to improve recommendation and provides with control over data what is shared. And again, variety and robustness. Similarly, it should be able to detect, right, even whatever others fraudulent transaction, it should be able to detect, and it should give the appropriate results. Okay. So that's why that's how the responsibility, and even there are a lot of research in this area also, how it should be, we have to make like ethical AI. So there is some audit, there's a company that coming up, right, a lot of startups that you can see, ethical AI companies, that's also coming up. So good. It's already passed. So we'll close it quickly. So one is now I have everything. So how do I adopt the enterprise? Enterprise in the sense all these organizations should adopt this model, Gen AI and all. So there is a lot of traction, and even if you see any market competitive analysis like Gartner or IDC, so you must have known there's a lot of focus. Here are some highlights where Gartner says 50% of the Gen AI models that enterprise use will be specific to industry or business function. So I was talking about the specific to industry like manufacturing, retail, something like that. It will be there by 2027. Right? Only 50% will be more generic. Okay, so there's IDC saying 40% of the enterprises in Asia Pacific consider code review and testing as one of the important tasks. Okay, that AI could most effectively help developers streamline. So you can think about the manual testing jobs and code that will be replaced by 48% very soon. It will be there. Similarly, by 2026 next year, 42% of the marketing jobs will be taken over by Gen AI. Okay. Similarly, 2027, 40% of the current job roles will be redefined. In the sense, what we do, we don't do, right? We have to do something else aligned to the industry and eliminates across global 2000 organization. That's what they're saying. Okay. Again, on the hardware side, there are by 2027, 60% of the enterprise will use a GPU. That's what you have a lot of business for the GPU makers, correct? All this like NVIDIA, AMD, right? All other things, people. Okay. And 2028, so Gen AI based tools will be capable of writing 70% of the software tests. Okay, so remaining only 30% will be written or modified by the coders. Okay, so yeah, this is quickly I can just show web crawler, right? So you might be seeing like when you search in Google, it gives you the relevant data under. So how they crawl it earlier, correct? So they have all these platforms and how they get the data, keywords, then other non-language they will translate and put it into some data lake, and the ability to understand using NLP process. Comprehend will basically help you to NLP. Then finally, all these things will be there in the analytical databases. Then you get to know through QuickSight or any visualization tools. So simple architecture diagram. So so we are running out of time. I am not able to explain completely, but this is how the flow goes when you have the web crawler and able to get the some case study. For example, I am running the company. I want to know what is the current trend, right? Particular topic, or what are the competitors? Is there any KPI that I can get out of it? So basically, there will be web crawler who crawl all this public website, get the data, index it, right? On the other side, you will be able to search it and get the insight. Okay. So this is again one slide talking about future of AI. So what is the one is autonomous system and robotics. I think you have the last session. It's mainly on the autonomous and robotics, correct? How you build a AI-driven autonomous system capable of handling real-world scenarios. Okay. Then again, healthcare, very, very important. So a lot of traction into it. Personalized medicines, wearables. So wearables is another domain where a lot of innovation is going on. Right? So how do we use small GPU or small SoCs which is compatible to wearables, get analytics, personalized recommendation, run AI in the edge, all those things. And explainable AI, a lot of traction. Similarly, other domains like manufacturing, you have digital twin, right? Or there is a AR, VR, XR integrated with AI. So now, I don't know how many of you know about Apple Provision devices and all. So you don't need to run any software algorithm to know the emotion. It basically, if you wear that device, and it will automatically sense and tell you which mood or emotion you are in, right? And that can also track eye tracking and other things. Similarly, education, healthcare, insurance, and retail, right? And all the enablers for this AI, mainly you have like wearables, right? Wearable and IoT, main sensors that you collect the data, you run models at the edge. Cloud, who basically provided to store analysis, right? And other things. And similarly, for the front end application for the visualization, like you have ClickView or Power BI, anything that you use, you can get this insights, right? Okay. So that's all from my side. Hope it's useful. And I think you overstood the time.
Sir, really your session was wonderful and informative for the participants. You covered the fundamental components of AI, which are creating the building blocks for the future. The participants gain a deeper knowledge of data science through the case study examples, which explore further research in AI. Overall, the session was really informative. Thank you so much, sir, for spending your valuable time with us. Participants, now it's a time to interact with our resource person. If you have any queries, please post your queries in the chat window.
Hope I'm not standing between your dinner. It's already 9 o'clock, right? 9 then, okay.
Yes, participants, if you have any queries, please post your queries in the chat window.
Okay. So security is, yeah, so I was talking about security privacy, right? It's very, very important. For example, like ethical AI, so it is. So for example, if you are training your model specific to your domain, okay, so you are giving all your data, right? You should not expose basically your data to anybody else, right? And it should be masked. Okay. Yeah, there is a security framework and it should comply to the standards, other things. But yeah, I'm not very in-depth into security domain, but there are a lot of things that we can do with the security. It's like other system, right? So it should behave ethically, it should not misinterpret, correct, and cut across all the layers, like from the infrastructure, correct, and algorithm security, then application security. So all the layers we have to take care of the security.
Is there any queries from participant side?
All right.
All right. If you don't have any queries, now I request from Priyanka madam to conclude the session. Over to you, madam. Priyanka madam.
Yeah, thank you so much, sir. I extend my deepest gratitude to Dr. Selvaraj Keshavan, the Senior Technology Architect from DXC Technology, for delivering an illuminating talk on AI fundamentals building blocks for the future. Your insightful discourse shed light on the informative impact on AI on society, offering profound perspectives on both its potential and ethical implications. Thank you so much, sir, for being with us and sharing your knowledge with us. Thank you once again. As we come to the close of this enriching session, I extend my heartfelt gratitude to each one of you for your active participation and engagement. A special thanks to our esteemed speakers, Mr. Gopalakrishnan S. and Dr. Selvaraj Keshavan today for sharing their invaluable expertise and thought-provoking insights. It has been a privilege to learn from such distinguished academicians and researchers. Tomorrow, we would all meet again online sharp 6 p.m. for 2 more sessions by Dr. Amudheval Jawal from De Montfort University, United Kingdom, on the topic High Performance Computing with Digital Twin, and by Dr. Vinay M. from Christ, deemed to be University, on the topic AI Innovative Strategies for Modern Applications. We appreciate your time and commitment to continuous learning, and we look forward to your participation in tomorrow's sessions also. Thank you once again, all participants, and have a wonderful evening. Good night.